I turned them on, and then I think the tab crashed or something. So thank you for your patience. Oh, I need to change my little Nightbot here. So let me change. Nightbot is still in the mode that we had for the co-working stream, which seemed to be fun. Folks seem to like that, so I'll look into keep doing that. Disable. All right. Okay, because we're not co-working today. We're doing some science today. Hi, Strawberry Jesus. And let's see here. Don't drink it dry, bro. You ask how my back is. Thank you. I'm doing better. I will say that the hardest thing right now is sitting. So stream had to get paused for a little bit because the hardest thing, honestly, was sitting in one place. So I've been switching while I'm working between sitting, standing, and kneeling on like a footstool. But every day it's a little bit better. So I will, gotta be grateful for that. Okay, so tonight I'm really excited because this is going to be the first stream in another series that I'm starting to do, which is the fundamentals of data science. And so this is going to be the first video/stream. If you have any recommendations for topics that you're interested, you want to hear more about a particular thing, or you're starting out in data science and there's things that you'd like me to cover, please let me know. Because unlike the 12 days of machine learning miss, this one I'm not planning like just 15 topics or just 10 topics. It's gonna kind of be like an indefinite sort of series that I'll just keep adding to periodically. But the first one, I thought a good starting place would be exploratory data analysis. The other fundamentals of data science stream that I'm planning on is model selection. But if there are, the topics need to be broad enough that, they're the fundamentals, but obviously like not so broad. You can't just be like machine learning all of it in one stream. So I have to kind of balance the two. And hi, Sasang Thapa, how are you? Strawberry Jesus, you seem to like that is indefinite. Yeah, so I was thinking about mostly, having themed series of streams because folks seem to really, really enjoy having a series of streams all on the same topic. So this one will be something that we're doing on Science Sundays. The other Science Sunday stream that I thought might be fun is kind of like an intro to astronomy. So I can plan that one another time. Right now, I'm just going to go with the fundamentals of data science. And good news, everyone, tomorrow is going to be our first Math Monday stream. So get excited. I'm excited. I like math. You should like math. It'll be fun. It'll start out real easy. So I think tomorrow we're just talking about numbers. So it's going to be gentle. It's going to be gentle. It's going to be fun. It's going to be comforting. It'll be good. All right. Okay. So let's see here. Before I get started, not number theory, nothing complicated. I want to start really basic. I'm also, my notebook's over there and I'm kind of forgetting what I had planned. But I'm pretty sure the first stream is just all on numbers and kind of a review of math that's K through 7, K through 8, so that people who, are just tuning in and they want to get started with algebra, I don't leave people behind from the start, essentially. And Manolob 2000, thank you for following. And hi, Era Wraith. And math is all about numbers, but I'm not starting off with functions, and I'm not starting off with polynomials or something like that. We're gonna start off simple and easy because I want it to be comforting. But in any case, tonight we're not doing Math Monday. Today we are going to be doing exploratory data analysis. And so let me get our whiteboard up here. Hopefully all of you saw, by the way. Let me just get this all set up. Canvas. All right, so this over here. This stuff over here. Excuse me, computer. Oh no. Well, we'll deal with that later. Okay, So hopefully all of you saw that there have been some changes to the machine learning myths repo. So or if you're here from YouTube, to the YouTube playlist, all the videos for all 12 days of machine learning myths have been updated. They all should have accurate timestamps. I've cropped out kind of like the intro music. They all should have kind of extended descriptions with links to the code. All of the code should be up. I think I have all of the Blackboard images up. If I don't, I'm missing like a single day. I've gone back through listening and I've been rewriting some of the Blackboard notes so that they're clearer for the days that I was missing. But all of the code, all of the videos should be up. Almost all, if not all of the Blackboard images should be up as both SVG and PNGs. Am I missing anything? Everything's up on YouTube. Oh, and for the fundamentals of data science, we're going to follow the exact same format, okay? So there's going to be a GitHub repo. There's going to be, notebooks, Blackboard images, notes, data, all of that's going to be on GitHub, so following each stream. So if you're here from the fundamentals or from the 12 days of machine learning myths, it should be a really comforting, familiar kind of structure. We're just going to follow the exact same kind of structure because folks seem to really like that. But let's see here. Lord Azazel, you say, but streamer algebra does have functions. It does, and we're going to talk about functions. We're just not going to probably do it on day one. And Sasang Thapa, you asked me if I'm going to use Matplotlib. We will use a bit of it. We're going to I think I use a little bit of Matplotlib tonight. There's kind of like a built-in Matplotlib functionality within Pandas that you can use. The syntax is really similar, so we're going to be doing some of that. And Lord Azazel, you say there is a book called Malware Data Science. Does that sound like something you delve into deeper? So I'm not a cybersecurity person. Like I did one cybersecurity project, like a really in-depth one, but still I did one kind of like security related project for work. But that's not really my focus. And I would say that's probably, while I could talk about the data science aspects of it, like I am by no means a cybersecurity expert. So I would feel a little out of my depth there. Hi, Ian Alex Hart, welcome. Okay. And all Hubble treat breaks, Loafbone is right. All Hubble treat breaks should also be tagged. Okay. So by popular demand, we're gonna be talking about exploratory data analysis tonight. Let me see here. That should be, yes. Oh, well, my lights, I still have Christmas lights. Hold on. Let's get rid of those. It's a little bit, I like them. They're all like themed and cute, but like it is a little bit, I can't keep milking the holiday thing. We've moved on past that just a little bit. All right, so let's get set up here. So we're going to be talking about exploratory data analysis. Can I do a straight line? Yes, I can. All right. I'm starting Christmas 2021 early. Oh, Lord. I just have a holiday stream 24/7, 365 days a year. Yeah, no. It's also like Christmas isn't my favorite holiday, so I feel like Thanksgiving is, but it definitely, I felt like for the 12 days of machine learning myths, we had to keep that theme kind of going. So, okay, so exploratory data analysis. I know I've still got my stocking up there too, Jeff Mack. That's because it's like, one, it was like a free thing through Streamlabs, and I have no other cute like animated overlays for like the top donations, so oops. I'll mess with it. I'll mess with it and change it in the future. I was like I've mentioned previously, I was running a little bit behind for this stream. My light collapsed, my green screen wouldn't work. Streamlabs had like some big update to do. It was a hot mess. So one thing at a time, but I'll get to it, I promise. All right. So exploratory data analysis. Why do you care? Why are we even talking about this? I know all of you, well, actually, I'm very proud of a lot of you because while we were doing the 12 days of machine learning myths, one of the most common questions I got was, are you going to talk about EDA and like how to explore your data and how to kind of like investigate it properly? So all of you are actually wonderful, but very commonly I see one of the common mistakes I see like new data scientists doing or new machine learning developers doing is that they kind of just like, they don't embrace this part. They're just kind of like, no, this isn't the cool part. The cool part's the machine learning. So like, whatever, I'm going to kind of half-ass it, and I'll make a checklist of stuff to do. I'll plot some stuff and then like not really look at it and just go right into the modeling. But here's the thing, is that this can save you, not only can this save you a lot of time and hassle when it comes to things like model selection, interpreting your model, tuning your model, understanding why your model's behaving terribly, but also if you are, working as a data scientist or machine learning developer, a lot of times you're working with data sets where you don't have like the subject matter expertise to really just automatically understand everything about the data going in. And even if you were a subject matter expert, people don't always deeply understand this massive, massive data set right off the bat, right? The more that you know your data inside and out, the more that you understand it, the relationships in it, the distributions, the patterns, the more you're going to be able to extract really, really useful results and analytics from that data, whether it's through machine learning or another method. So let's start with what exploratory data analysis is. So I'm also going to start calling this EDA because I don't want to have to keep saying long words. EDA. All right. Let's make sure. Yeah, okay, I got my good colors. All right. What is EDA? And this is something that you might think it's really simple. It's right there in the title, exploratory data analysis. We're going to explore our data and analyze it. Well, at the most basic level, you're absolutely right. However, I will say there's a lot of misunderstandings about what EDA is, what it isn't, where in kind of the data science workflow it falls. Oh no, don't tell me the closed captions still aren't working. Lovephone, seriously? I am looking right at them. They're telling me they are working. I'm getting all of like the stuff that says they're working. Please. I tagged this stream with closed captions. So Lovephone, I might need to have you edit and pull that tag out if the closed captions are pooping themselves today. Okay. I think we're supposed to get snow Thursday as well, Loafbone. That's frustrating. Okay. So exploratory data analysis, what it is. This is the process. I had a nice little definition written out. Let's see, what did I say? The process of analyzing data to deduce stuff. What kind of stuff? I want to use yellow. We could, like, one of the things that I think is really important is you can develop, and this is what I was talking about earlier, like a deeper knowledge and intuition about your data. Let's see, an insight. How did I phrase this? I sat down and I wrote some good definitions into the structure and content. Yeah, look at me. Go me. I was thinking this stuff through. The structure and content of the data. No, hold on. I'm going to mute my phone. Silly me. I usually am pretty good about that, but hi Icy Yogi, welcome. You ask how I am I feeling better, how are my parents doing? Well, I'm feeling better, slowly. Every day my back's doing a little bit better. It's been an adventure. Definitely felt like an old lady the last week or so. My parents are doing a lot better as well, so thank you for asking. I think both of them are recovering well. It hit my mom a lot harder, so she was, having that kind of difficulty breathing and coughing a lot, but she says she's feeling a lot better, so I'm hoping they'll be back to normal soon. COVID is icky. Wear masks. Get your vaccines. Okay, so what does this mean? Developing deeper knowledge and insight into the structure and content of the data. So this is things like, if you just download a data set or you get a data set from somewhere and you just slap a model on it without even looking at it, when things start to fail or you have really strange results, like maybe, you're trying your linear regression from day one of machine learning this and you're like, wow, why is it doing so terribly? Why am I getting such poor performance? If you don't understand, what are your features? What's the range of your features? Are they categorical? Are they continuous? How are your features distributed? How are they related to each other? Those things are results and insights that you can get from doing good EDA. And so that can help you not only prepare for your model better, but also pick the right kind of model, and pick the right features. So hopefully I can sell you on the importance of EDA. I do understand why some people are kind of like, hold on, I'm gonna skip this song. I want like a little chiller music. I find it hard to talk over music, so I try to pick chill music. But so one of the reasons that I feel like a lot of people pick this is that they assume the only thing that's in EDA is data cleaning. And while that's kind of like, sometimes people see that as a pre-step, sometimes they see it as like kind of part of EDA, but they think, oh, data cleaning, just like making sure, there's no typos or like, our categorical feature has been encoded or something. That's all EDA is, right? Like there's so much more to it that we'll be going into today. So if you kind of think this is a useless step or a meaningless step, it might be because you don't fully understand what all the coolness that EDA can cover, and hopefully I can convince you of how necessary it is. And Sasang Thapi, you ask, could you tell us the difference between data mining and data science? Sure. So data science, I would say, is much, much broader. Data mining is just the process of scraping data from, like you could mine tweets, you could scrape like, content off of blogs. But while data collection is definitely part of data science, it's only one small portion. So I'll actually be going into a little bit to give you context for EDA. I'll go into kind of like the data science lifecycle and where EDA fits, and you'll kind of see where data collection is in as well. Okay, so what else do we want? We can, and those of you who are here for day 5, I think, of Machine Learning This will like this one. We can identify outliers or anomalous data. And the reason why this might be important, right, is that this is something I'm going to come back to later, but a lot of machine learning models will rely on measurements like the mean or the average, right? And if you have a lot of outliers in your data, something like the mean might be less reliable. And so when you're having those, what we call measures of central tendency, if you're going to be relying on those, you need to understand how your data is distributed. You need to understand if there are outliers that are skewing things, or if you have a lot of really anomalous data that might be kind of adding noise. Characterizing those outliers and those anomalies is definitely part of EDA, and at the very least, identifying that they're there can be really, really important. You also, this is where you can test any kind of assumptions or hypotheses you might have about your data. So that could be things like, in the data that we're going to be working with today, not to give too much away, but we're going to be working with world happiness data. And so I went in when I was kind of designing the EDA for today, and I didn't sit there and kind of prescriptively go, oh, like what boxes should I check? I went, no, let me sit down here and work for an hour on this and just do what I would normally do. And that way, when we're going through it together, you can see authentically, this is what I did. These are the tests I ran. These are the visualizations I made off just kind of my normal process. And so, one of the hypotheses I had is that hopefully for the let's say the top 5 countries that had the highest happiness scores or whatever, I would predict that those countries probably would see, if anything, increasing happiness or little to no change in their happiness scores over the 4 years, 5 years that we have data. Because I thought, okay, well, countries that are that high, they're probably investing in good social programs and things to help keep their citizens happy, right? Well, I was wrong. And I thought that was really, really interesting. But, another kind of hypothesis I had is I bet, what's one of the measurements? Economy is definitely one of them, but there was one that was freedoms, they're kind of freedom index, and another one was, what was it? It was like social support and family. And I was like, well, those things seem intuitively things that would be correlated with happiness. You can test those intuitions, because if you're right, that kind of, those correlations between your features can affect your model, but also that allows you to kind of already start getting useful insights from your data. Because if you're doing this, as as a personal project, or even if you're doing it for work, the sooner you can start to get value from your work, the better. And EDA can give you a lot of value right off the start before you even start building a machine learning model for something. And yeah, I don't know why the closed captions are broken. I did everything I normally do. I'm so sorry. I will look. I restarted. Yeah, Loafbone says I restarted the stream to try to fix it. It's still not working. This is like a third-party tool that I've been using. It seemed to be really reliable for the 12 days of machine learning miss, but I will I'll look into it and hopefully get back to you. I'm sorry. And let's see. You can determine. This is really important, especially for those of you that are interested in machine learning. You can determine your key features, or you can start to scope the need for feature engineering. And like I would say in the real world, you're always going to need a certain degree of feature engineering, because no real raw data sets just like come to you in perfect form, like with a lot of the ones we were working with for like the machine learning streams. So you're going to have a degree of feature engineering with, I would say, every single real data set that you use. But different data sets, you'll start to get a sense for like how much you're going to have to do feature engineering. Some, it's easy, like you just need a little bit of tweaking, or you need some like normalization, or you got to like, encode a few categorical variables or something. And some you're like, oh boy, this is going to be an entire process unto itself. So this is when you can also start to kind of look ahead and be like, I think I know how much work this is going to be. And you can start to identify features that are going to be key in whatever model you build. And Gohaka, you say, this is a cool stream topic. Any books or resources to get better at EDA? Yes, actually, I can recommend a few books. Are you looking at doing this in any particular language? And let's see, Kriegersaurus. Rex, you say, data isn't simply handed to you perfectly on a silver platter. Absolutely true. And that is honestly, those of you who might have done like boot camps, or maybe you've done some tutorials on data science already or machine learning, a lot of times people are using those classic data sets that kind of we went over in the machine learning streams. Your Boston housing data set, your Iris data set, your Titanic data set. These are data sets that have, for the most part, good class balance. They're really cleaned. They're like, they fit well. They're designed to like work well and teach people how to build machine learning models. So many people, I can tell you, new data science, like junior data scientists, one of the first things a lot of times that they come to me with when they've started working on real projects is like, why are all my models so bad? Like everything I built, nothing's working. Like what am I doing wrong? And a lot of times it's because they're just so accustomed to these boot camps and tutorials where you do a little bit of EDA maybe just to say, oh, here's how you, use Panda's core method or something. And then they go right into slapping on a model out of the box, very little tuning. And it just works. It works like, 96, 97% out of the box. And so there's actually very little, and this is something that maybe I should add this to my fundamentals of data science. The stream series is like a troubleshooting your model stream, because that's something I don't see taught a lot of times. I see a lot of, how to build the model, memorize all this math and statistics. Here's how you build the model. I don't see a lot of, okay, in the real world, it's very, very rarely going to work right out of the box. So here are like the tests you can start to do to see what's going on. Here's the steps you can take, to start to analyze and diagnose what's going wrong with your model. I don't see that taught a lot. And so one of the things that helps you figure that out once you've built your model is having a really good solid foundation of exploratory data analysis. So, and then I think I already talked about the next one, so I won't waste space. Okay, so I think one of the things, though, although we have a list here of like cool things that EDA can do for you, I don't want people to think about this like a checklist, a to-do list, a bunch of like, tools in a toolbox that you just take out and you hammer at the problem and then you put them away and you say, I'm done. So if anything, this is, explain it. it's a process. More often than a process, it's usually a cycle, and we'll get into that. But this is like, I want to emphasize this process portion, right? This is kind of like it's an active process, not, I guess, a checklist. I keep coming back to that, or like a to-do list. It's not something that you should engage with passively. You should kind of like, this is when you can have your scientist hat on, your like investigator hat on. This is the time to be actively thinking about your data, asking questions, chasing down theories. And then, once you've done all of this and you feel like you know this inside and out, the model is just kind of like a natural progression of that. But this is where the fun starts. And like I said, although this is kind of, it's seen as distinct from data cleaning, a lot of times those processes will go hand in hand. Like a lot of times when I'm doing my EDA, I start doing my EDA the second I have data. And I'll be cleaning the data, but I'm also analyzing it. I'm exploring it while I'm cleaning it. Okay, let's see. All right, so yeah, let's talk about, because this came up quite a bit when I've taught people previously. It's kind of like the data science life cycle or the data science process and how EDA kind of fits into this. You do need your I said you do need your detective hats. You do, absolutely. Did I misspeak? Oh no. I'm sleepy today, so if I say something that makes no sense, like, call me out. Keep me honest, generic crew. All right. So, what do people think are steps in the data science process? So, we'll brainstorm first. Like, let's see, what is part of data science? Because I think this is where data science has almost become a buzzword. So what do people think are, what's part of data science? What are some steps that you think might be part of this? And let's see, Delta Rulo, yes, you say make a hypothesis. Okay, so we need to, I like that, make a hypothesis. What else? It doesn't have to go in order, by the way. So any steps that you think are part of the data science process. And let's see, Gohaki, you say, do you recommend Head First Data Analysis, O'Reilly, or EDA by John Tukey? Off the top of my head, I mean, I found O'Reilly's series excellent. There's a really good, like, intro data analysis, data analytics book that O'Reilly did with Python specifically. But the name is escaping me. We were talking about it on Discord, but I can get back to you with that. And Delta Low, you see what data you're able to acquire. Okay, so maybe like collect data. I like that. Krieger Source Rex, you say create a target variable. Okay, so that's kind of like in the like either identifying features or maybe starting to choose a model. Those are definitely all part of, because you saying creating a target variable, that already implies some kind of like supervised learning, right? Oh my goodness. Okay, wait. Oh, thank you, Love Phone. I will wait a second for the raid to enter chat so that I can say hi to Simuleos and not get overly excited. Oh, yay, no, you're already here. Hi, Simuleos. Thank you so much for the raid, and welcome, readers. And thank you, Icy Yogi, for resubscribing 2-month streak. Woohoo! And Strix and Professor Saucecat for following. Welcome to my new series of streams. So this is going to be the fundamentals of data science. I'm just going to... I don't have like all of the topics, unlike the 12 Days of Machine Learning Myths, where like I came in with 12 topics and I knew what each stream was going to be. I haven't scoped out all of them because I see this as more of like a long-running series. But so far, I think, what have we decided? Definitely, obviously, this stream on exploratory data analysis. I feel like there definitely needs to be one on model selection and one on like model troubleshooting, like what to do when your model goes wrong. But other than that, I'm open if folks have topics they want. I would say just give me that feedback and I can prep a stream for it. And Delta Reload, you say, understand the data that you have. Well, my friend, we have a word for that. What is this stream on? I love you all in chat, but I ask what is part of data science, and not one person so far has said the one thing I've told you is definitely part of it, which is EDA. You goof. But yes, so that is part of EDA. Strix, yay, you say you saw my machine learning series on your YouTube recommended page. Yes, okay, so like the YouTube algorithm is actually picking it up because obviously I just started the YouTube channel as more of like a dumping place for VODs at first, and then I went back, actually edited the videos a little better. I put more effort into like the descriptions and like the links and everything, so hopefully people can kind of find stream through there, or if you're not a big Twitch person, people will find the YouTube. So I'm glad you're here though. That makes me happy. Like, I exist on YouTube now. Okay, so we've got like data collection. Yeah, so I think Justo, I think this is kind of under data collection, right? So different data types, understanding the data you have. So choosing model, what else do we have to do? Like, what else is part of data science? I'll like scoot this over a little bit so we can add more stuff. Do we just pick a model and that's it? Like, well, we're done, collect our paycheck. Am I internet famous now? Hardly. I think I've got like 150 people subscribing to me on YouTube. My brother has like hundreds of thousands of people, so I'm nowhere near internet famous. Oh, okay, and just so you say databases. So yeah, like, so maybe we need to also think about storing our data. How are we gonna store it? How are we gonna access it? How are we gonna organize it? Those are good things that are part of this. What else? And eventually, you know, we'll build this out into a, Jeff Mack, I like that. You say visualizations. So I'm gonna take this, I'm gonna run with it a little bit. I would say visualizations are fundamentally a part of communication, right? So there's kind of like a communicating our results. That's absolutely part of data science. And I will say this, oh no, this is a soapbox, but I'll make it a very short soapbox, which is, I can't tell you how many visualizations I've seen of data science, or like, oh, what's part of data science? And they want to hammer you and be like, yeah, the math and the statistics and the machine learning and like data analysis and data engineering. And so many of them neglect to say communication, when I would say that is one of the most crucial parts of data science. Like, you cannot accurately and effectively be a data scientist unless you can communicate your results effectively as well. So that just, maybe so frustrating. Yeah, okay, so you're getting there. Maybe, but what happens when we build the model? Like, so even in your process, Justo, you think it's intake, so collecting our data, then pre-processing it, and analysis and model building, and communication. But like, there's stuff that's got to be between just building our model and communicating the results, right? Like, come on, friends, you were here earlier, right? When I was saying your models never work right out of the box. I promised you. If they do, something's probably wrong. Oh no, Professor Sauce Cat, I missed you following. You have an excellent name. Yeah, so like Jeff Mack, you say troubleshooting. I might say like, we call this evaluation, right? So we want to evaluate the model. Yeah, tuning. Okay, evaluator, like, I like that. And tuning the model. Okay, so what this actually looks like when we kind of turn this. Oh, I didn't miss it. Did I already say? Oh, I just really like your name. I got excited, okay? It's a cool name, and especially when people have fun names that I can actually pronounce. I got too excited. Okay, so remember that I also said I would rather think about this like a cycle instead of a process. So what this might look like is, I think like the first step is to define a problem or a research question. Now, this can be very broad. So in my experience, this could be anything from a client handing you a data, like massive database, and be like, you know, what analytics can we collect from this? And you're sitting there like, what do you think that word means? They just like, so many clients see data scientists as this like data wizard that can just like, here, take my messy, incomplete, terribly stored, awful data, get me analytics. And I always have to be like, well, you know, what would you hope to get from this? Like, you know, what do you see analytics doing for you? Because it's another buzzword. And then it's like, you push and you push and you push and you finally kind of get to the, like you want to know the relationships between these things, or you want to know how to optimize this process, or like whether changes you've made have been effective in this way. Like, so, hi, Justice Good Joe. Um, and let's see. It depends on your goal. Yes, it does. Well, I would say in data science, a lot of times we'll use model very loosely here. So model doesn't have to be machine learning model necessarily, but like even if your model is something really basic or it's like passive and you're kind of more looking, how to put it? Your model doesn't have to be predictive. Let me say that. It could be prescriptive. So you could still use something like a regression, for example, to help somebody answer the question of like, what should I do to cause this effect? Just as much as you can analyze what has the effect been as well. And so let's see here. Oh, and Strix, you used a GitHub command. I do need to change the Nightbot. So there's going to be a lot more than just machine learning myths on the GitHub. So the code for the fundamentals of, what am I calling this? The fundamentals of data science? Foundations of data science? What did I say I was going to call this? I should kind of make up my mind about that. I want to say it's like, anyway, regardless of what I'm calling it, the data science stuff will be up there as well. So not just machine learning myths. Okay. So after we define our problem or our research question, I'd say, I won't try to change too many colors. Our second step here is going to be to collect and store the data. And so this largely, this is kind of where this is going to be like data engineering. Though I've also seen a lot of like this term data engineering used to cover a lot of different things that I would not think are data engineering. So sometimes there's also the problem of like the more people use words, it seems like they change meaning. So, and just to say, at least in your experience, descriptive stats are often asked for outside of dashboarding tools, not only using Tableau. Yeah, and so dashboarding and visualizations can be part of this. Absolutely. I don't really like that step personally. I'm very bad at that step. Bye, don't drink and drive, bro. But I would say, actually, I found sometimes the opposite. So a lot of times, like in the visualizations that you're doing in like Tableau or whatever dashboarding tool you want, it's important to have things like the averages, kind of like you're having kind of error bars or having distributions of things visualized as well. But step 3 usually I would say is like preparing your data. And so this is really broad. So I actually would like, if I could shove a whole bunch of things in here, I would say we've got cleaning data. We've got EDA. And we've got our feature selection and engineering in here as well. Under this like very massive head of prep your data. I also, how many? I have 7, so let's make sure I'm giving myself enough room for a cycle. I'm really bad at drawing these like cycles and stuff. Okay, so we'll maybe put 4 here. 4 would be model selection. What model type are you gonna use? And yeah, so like just so you say model here refers to creating the thing the customer wants. So if your client wants, they're not looking for predictive analytics and instead they just want like a dashboard or something that shows them trends or shows them relationships, like we'll use model like really loosely here. So this could also be tool selection maybe. The kind of data science I do, like my hat is almost entirely as a machine learning engineer and developer right now. So it's been a long time since I've kind of had to do the more like analytics oriented versus machine learning oriented. So I'm gonna keep model selection in here because we've talked so much about machine learning that I want people to see kind of where what they've learned from me previously fits into this kind of broader scope. And then Mr. Ed makes, you say, is there a need to do something to ensure the human bias is not introduced to the data set? So I would say that comes in a couple different places. If you're talking about, and thank you, Vali, for following. If you're thinking about like where do we analyze for bias, I would say every single step of this. You should have, bias can be introduced every single step of this process. And so analyzing and kind of like being really conscientious about what biases you're introducing and how they're introduced has to come at every single step. Because sometimes even just the way that you phrased a research question or the data that you've collected already has a bias, or some assumption that you've made is introducing a bias into the data or into the model. And so when I'm saying bias here, Justo, you say it's itself a statistical estimator. I'm also using this in the ethical sense of bias. So in machine learning, unfortunately, because of that, it's a statistical term as well as an ethical term. There's a lot of people ignoring the ethics side because they're like, we accounted for bias. We're not talking about bias here in terms of bias and variance. I'm talking about specifically ethical bias as well. Yeah, and it's good to clarify that there's both, especially when I find that the ethical bias is very frequently not considered. Okay, so this is where we'll say like model evaluation. Then, oh yeah, this is actually gonna end up being a circle. Sweet. This is what we'd call model deployment. And so we haven't really talked too much about this because we've really been focused on, in machine learning myths, steps 4 and 5. Today we're gonna be focused on more step 3. But model deployment is often where kind of like the software development comes into it. Because it's one thing to kind of build a model and test it and be like, yeah, this works great. It's an entirely other thing to build software that your client can use in whatever their environment is, on whatever hardware they have, which can vary drastically, with whatever kind of constraints they have. And this is where a lot of considerations go into like, when should we refit? What should like our testing frequency be? If we are collecting and storing new data, like how are we going to do that? How are we going to update the model? What kinds of, calibration or like limitations are we going to put on model performance? Things like that. That's when all that fun stuff happens. And then I would say either in between. Well, communication should kind of happen at all stages. But if we're going to make this some kind of cycle, I would say this is kind of when the communicate results happens. But here's kind of the interesting thing, right? Is that right here in model evaluation, you can find that, we've picked the wrong model, something went wrong, oh no, like we have made a mistake. And so you almost have like a little sub-cycle in here that could go, maybe you need to redo this, maybe you need different data, maybe you're asking the wrong problems. So this is less even a cycle and maybe more of a spiral. Like you can circle back. It's kind of like this organic, constantly evolving process, and less of like check to step 1, now I'm on step 2. So, and thank you for linking Professor Saucecat to the YouTube Love Bun. And so a lot of times though, like you'll see this stuff here. This is where people will say like, if they're hiring for a data analyst, a lot of times they're talking about step 3. While I would say data scientists should be able to do all of this, this often is kind of like your machine learning engineering. Though I would also argue that that kind of includes 6 as well. Though this is the interesting thing though as well, is that there are a lot of machine learning developers who work in very kind of almost like sterile spaces where they're just interested in kind of like the research question of how do I make a model to do X, or how can I predict Y from Z? And they never actually have to worry about how to build the architecture of the model in terms of like software and deployment. So this is like a tentative link. Maybe I should have like made this a slightly different color or something. Really depends on the place though. And this is why like these terms have become difficult, because when you're hiring someone who's a data scientist, I've known data scientists who are everything from just data engineers to just data analysts to somebody who can do all of it. So I guess like the equivalent would be like a full stack data scientist would be able to do all of this. But what's interesting about this kind of like data science life cycle, right, is for those of you who maybe have more of like a formal like science background, right? What's the scientific method? And Angela Rainbow, thank you for following. Welcome. So if you look at the scientific method, this is really interesting because these two cycles mimic each other very well. So in the scientific method, right, you define a question or a hypothesis. You gather your data. Here's where you form your hypothesis here. Noir Zox, thank you for following. Then you test your hypothesis, and I'm gonna put in a reproducible way. And Unbound Miracles, thank you for following as well. Then you analyze your results. You like form a new hypothesis or new conclusions. Or you edit, I would say, form new hypothesis, or you edit your old hypothesis, you update it, draw conclusions. And then what do? You publish, you communicate, right? And then, other scientists come in and peer review and reproducing your results. Well, look at these cycles. They're very, very similar. And in fact, whenever you're doing data science, you should be focused, you should follow best scientific method practices as well. So things like reproducibility, explainability, being able to communicate your results. People should be able to reproduce what you're doing. Having good scientific integrity about documentation and about your hypothesis and assumptions made and constraints. That is not always done, but I'm going to be prescriptive and tell you that it should be. And let's see, you say, you would argue they don't, Alley Cat. Models come after data analysis. You don't fit the data to match the model. It's not that you fit the data, models come after data analysis. Yes, model selection comes after data analysis. Yep. And so that's what we have here. And in the scientific method though, you gather your data, you have a research question. So for example, research I've done. Our research question was, what is the relationship between host galaxies and their supermassive black holes, right? That's not a hypothesis, that's a research question. So then we gathered a whole bunch of data, and then we formed a hypothesis, which was, after kind of looking at our data, doing kind of our EDA, data gathering and EDA, we formed a hypothesis about the relationship between certain features in the galaxies and certain features of the black hole. Then we tested our hypothesis and we analyzed the results of those tests. So I would say it's not that you're fitting a model to the data, you're prescriptively deciding on things, but you do have a hypothesis and you test it. But you often have this research question that you get beforehand, but it's not necessarily I think this is the case. It's just it's a question. Your hypothesis is kind of your answer to the question, what you think that question is going to be. And in the data science life cycle, a lot of times, it's the same thing. You define your research question, has changing our process made any effect on our customers or something like that? Then you either probably already have your data, but you collect your data, you prepare it, and there's where you start to see relationships, and you might make, a hypothesis there of I wonder if, this is where you get your data intuition from. So, Professor Soscat, you say in the oil industry, for example, a lot of interpretations are done just to be done. There is no background question to answer. Well, I would argue that's not good science. If you're just doing it to check a box, that's not really science. That's just something that you could almost automate at that point. But if there are we need to continue doing these same analyses every year or every 5 years to track the effects of something or to ensure that we're still performing up to standards, that's still a question. It's just kind of a little bit of an implicit question versus this explicitly stated research question. So I think a lot of times the question is there, but sometimes it can just be especially in unsupervised machine learning, right? When we had this, and we were just what are the patterns here? What can we do? What patterns can we discover in our data? That can be a question as well. So just does this show us anything useful? Is this meaningful data to collect? Those are questions just the same. So it doesn't have to be this perfectly scoped out, wonderful research question, but you should have some kind of some kind of question in mind. And Professor Saucecat, you say that's why the work the industry is doing is separated from an academic. Well, I work in industry, so I think it might depend on the industry as well. But I would say, like, in data science at least, you should have a hypothesis. You should have a research question. You should. I will say that that's something that I've had to fight against sometimes, is like, maybe that's more of like data analysis, that sort of more passive step, right? So like if you're hiring maybe a data analyst, you're just kind of like, I would say still like to have a curious mind, you're going to have those questions. But that sort of passive approach is one that like I've definitely had clients hire a data scientist, me, and want somebody that just kind of like, oh, just do our Tableau visualizations. I'm like, no, that's not my role. Like that's not, I'm not going to just do that. And I've had to kind of push back a little bit myself. So I would say, like, especially if folks are more junior data scientists or they're like earlier in their career, you should feel comfortable being able to like speak up with integrity about this, because just checking boxes with, you know, I did this analysis so we can say we're data driven, that leads to almost like a kind of, it defeats the purpose of being data-driven in the first place, which is that we should be getting insights. We should be getting results from our data and being like using that in meaningful ways to improve what we're doing. But I mean, there's also like the difficulty of like the real world, where sometimes people they see it as like another kind of bureaucratic box to be checked versus like actually a scientific research process. So I can understand thinking like some of this might be idealized. I would say it's a red flag if this is not how it's being done. So, okay. So let's see. We talked about that. Okay, so things to look for in EDA. Things to look. Oh my goodness, I'm like going down the page here. Things to look for. Okay. So, give me 1 second here, friends. To drink. Okay. So let's talk about things that we can look for, and then we're going to do this. But this is, again, like, I can't stress this enough, that while I want to, like, show you how to say this. While I want to give you tools to use and things to look for and, you know, types of analyses that you can run, I don't want at all any of you to sit here and be like, I'm going to make a list and then every single time I'm going to do this exact same thing. Like, it is a very creative process. It's like, you can kind of be like, this is your curiosity. This is time to let your curiosity drive you. And so that's honestly when I picked this data set, I was like, oh, this looks like a cool data set. I sat down, I started to like clean it, take a look at that. I was like, ooh, now that's weird. I wonder what like the relationship between these things are. Like, I wonder what this looks like. And so this is where the fun begins. It really does, in my personal opinion, at least. Because while we're about to talk about, you know, different kinds of statistical things and, you know, visualizations and whatever, don't lose the sense that this is all about that curiosity when you have your data. Like, what happens if I do this? Like, you know, what about looking at just this 1 year? Let's compare these 2 years. Or what happens if, you know, I compare these two variables? Are they related? What happens if I drop this variable? This is the fun part. And Boot Keen, thank you for following. Yes, a creative approach. And like, so I do want to say one thing, which is that I have heard people say that EDA is more of an art than a science. And one, I feel like I hate the kind of like art versus science line, first of all. But two, I feel like I have heard that be a red flag for when people are like, manipulate the data to make it look like X, or like massage the data until it does what you want it to. No. So when we say it's a creative process, it's because you have a lot of power here. Don't be like super prescriptive about, I should always, you know, make this graph and this graph. Like, let your curiosity and your own intuition drive you, and you can be creative about it. Like, ooh, like, I wonder what happens if I do this, or like, oh, this is a data set about, I don't know, like dogs. I wonder if, what if I group dogs by country, like what are the most prominent characteristics? Like just let whatever you're curious about, let that push you. Sawtech is saying people think you just take data and throw it at a logistic regression and boom, you have smart AI. Oh my God. I know. Like I like to talk about regression because regression can be very powerful, but the amount of people, I've seen a lot of sass and like memes and stuff of people just being like, machine learning isn't anything but like linear regression, and people thinking that, that's machine learning. And I'm like, okay, look, all right, like if I were to show you, a massive convolutional neural net or something, like, no, we've moved beyond simply just feeding our data to regression. Like this is really a different beast, but that doesn't mean that like regression isn't somehow also useful. So, the memes. I don't know. I sound like a crotchety old person just being like, these youngins with their memes. But like, just sometimes the sass about data science gets me cranky. Generic Creed say my linear regression can't drive a car itself. What have I done wrong? Oh my God, right? It's like people who say machine learning is just statistics. I'm like, okay, it's statistics heavy, absolutely, but like, there's so much more to this. Sounds more like LinkedIn than memes, Professor Saucecat. Well, certain areas of Twitter feel more like LinkedIn than maybe social media. I'll say that. I think you're right. LinkedIn's been like depressing me lately. So, okay. Things to look for. Let's talk about distributions. And so I'm not going to go through a bunch of distributions. We could have a whole stream on that if we want. We could make that one of our Math Monday streams. There's lots of different ways that your data is distributed. But this is also, I feel like, let's see, distribution, I would say, and like features. But this is, I feel like this, for a lot of people who are starting out, they hear like, oh, like what's the distribution of your features? They're like, what does that mean? So like, I'm going to break this down into maybe questions that you can start to ask. So a good starting place is if I write all this out, we're going to be here for hours. So let's actually just do this. Categorical. Are your variables categorical or are they continuous? What does this mean? You can also think of this as like discrete categories. Obviously, that's where we get categorical. Like this is where these are like eye color. It's blue, it's green, it's brown. These are separate categories or labels, right? Not in the machine learning sense, but like as in tags, however you want to think about it. And this is like your variable could be any number. So it could be any value in a range. So that's like price. So if I'm gonna like give you examples here, maybe this is like price, weight, temperature. A lot of these are like measured, right? Whereas this could be things like, I don't know, like I said, eye color, model of a car. Okay, like when we were doing the iris data set, species. Gender, stuff like that, right? Categories versus continuous. So that's something that you want to look at very early on in your EDA, because if you're going to be doing a machine learning model, what do we have to do to our categorical variables? We can't feed those. Those aren't numerical a lot of times, or if they are numerical, they could be like, I guess if they're numerical, you're fine. If they're just like binary or something. But you have to be careful because some things say like the months of the year, right? So a lot of people sit there and go, oh, I'll just code those to like 1, 2, 3, 4, all the way through to 12, right? Done. Well, you have to be careful sometimes because the months of the year, there's a cyclicality there. And 1 being January, 12 being December, those two are closer to each other than, December to, oh God, I'm going to screw this up. December to like September, right? But they're going to look much, much farther apart. So you have to be careful with how you do that. And yes, Sontag, you could do one-hot encoding or like some kind of embedding. Generic Crew used k-nearest neighbors and it can't tell me who my neighbor is. What is this talking? Oh my goodness. I feel like that should just be like a whole bunch of, I want somebody who's more talented than me to like make little like one cell, like cartoons, like comics of that, because oh my God, that would just, Oh my gosh. Okay, so if I can tell a brief story time. I had a project one time where I had a client who was like really, really, really suspicious of anything coding, anything machine learning, because she was kind of like, if I don't understand it immediately or I don't already know about it, I don't want to, I don't think it's, I don't think it's worthwhile, instead of being like trying to understand something new. And she had a very like, I think her background was like politics or like sociology or something. So it was like anything math related for her was just not going to happen. So I was like, okay. So I did the most gentle regression. And I didn't even show any math or anything, but I made like a visualization that was like, I don't know, like, let's say we're doing, okay, so like, year, plus like, I don't know, the color of something plus like the size, right? Like equals, move this over, like equals the value. It was something real basic, like, and I wrote out the words like this, and I didn't even have the parentheses. So like parentheses maybe are scary for some people. So like I didn't even have that. I just had something kind of like this as a visualization on a slide deck, like showing the results and everything. And she was like, there's too much math in this slide deck. And I remember just being like, she's like, there's pluses and equal signs. There's too much math. And I was just like, that was a rough day. That was a really, really rough day. So, yeah. The memes, like the cartoons, like sometimes that's the, I need that stuff because good Lord, you sometimes have to have a lot of patience and a sense of humor. Yeah, I died inside too, Kriegersaurus Rex. I am grateful for one thing, that like that project nearly made me leave my job. And when it got to that point and I was like, hi, I have offers to work elsewhere because I've been telling you this is miserable and you people won't listen to me. Like my company made a really great counter offer, pulled me off the project, gave me something new. So I'm grateful for that. But it was like, that was a year and a half that I was a grumpy human being for a solid year and a half. So how do you even deal with that? Oh, video games? How did I deal with that, Loafbone? I don't know. I was not happy. And I got loud about it near the end. So I'm not even sure I did deal with it. And Sontag, you say, being in tech is rough sometimes when the average person wants all tech and math abstracted out. Feels like no one sees your work sometimes. Ian Alex, hi, thank you for the bits. Actually, once we finish up the notes and we are transitioning to the code, we'll do a dog break. So I think I've got a tally right now with four dog treats. So we're banking them. And Sontag, I feel you. So on the one hand, I think that anyone working in tech, especially if you're creating products for non-technical people, needs to be able to communicate the value of their work and communicate kind of the process and like the results without talking over your audience. At the same time, though, like it can be so hard when you're the only technical person and you've made something really cool and like nobody knows the work that went into it. Like for that same client, I built them an entire from scratch ETL software plus a top layer of machine learning and like interactive dashboards. Everything automated because they didn't want to pay for any licenses and they didn't trust like any kind of pre-existing software. So I just built it all from the ground up for them. And they were just kind of like, oh yeah, cool, like nice, awesome, whatever. I was like, do you realize how much work this is? Like, do you realize that I built you something that would be extremely expensive if you bought it? And I did that for you in like 4 months? Are you kidding me? But still to this day, like nobody else was technical on the project, so they just didn't get how much work went into that. Ugh. Ad K Yari, thank you for following. Okay. Mr. Bullen, you say the opposite happens as well. You get massive amounts of praise from some of your clients for very little work. I've had that too, but I mind that a lot less. Because, like, they're so appreciative, even for something small, that you're like, this is impressing you? Like, just wait. Like, okay. I don't know. I don't mind that as much because that shows me that when I really do something amazing, they're going to be excited. And sometimes it feels nice to get appreciated for the small stuff, to be honest. Okay. So distributions, what else do we want to look for? So, you know, when you're looking at distributions, right? We could talk about a lot of different distributions, like, you know, I don't know, Poisson, Bernoulli, like binomial. There's so many, there's like literally, I can show you that there is like a 200-page section of a textbook that's just on distributions. So like that's not what we're going to talk about today. But things to keep in mind are what you can call like your measures. This is the fancy word. Measures of central tendency is a fancy frickin' way to say, how do we define the middle? So this is going to be things like your mean, your median, mode. And why this might matter is because if you have different kinds of distributions, different measures of central tendency will be more useful or more accurate. Let's see. Mr. Boolean, you say one of your current clients is a bunch of scientists, like you're talking 2 to 3 PhDs, each NASA level scientists that make microchips, and they praise us so much. Yeah, that's gotta feel really, really cool. Like, I switched from that awful project I just described to one where like that's kind of where my clients are now. They're like more engineering than software, but I know somebody else was talking about software, but they're engineers, and like the praise that I get means so much because I'm like, all right, you people are experts. Like, you're very, very senior level, brilliant people. So when you give me praise, like, it means so much more. And Mr. Boolean, you say, can I teach you machine learning? You like my style of teaching. I'm so glad. Guess what? There's 12 whole videos on the basics of machine learning. I did the 12 Days of Machine Learning Miss, covering everything from regression to reinforcement learning to computer vision. And so that was a marathon. But that is also part of this, like, I guess, fundamentals of data science, foundations of data. What am I calling it? I need to pick. Series that I'm going to be putting on YouTube as well. So we're going to talk more machine learning, I promise. So stick around. But to do machine learning, you do have to know your EDA. And yay, thank you for following and subscribing on YouTube. Yay. Like, I got so excited when I had like 100 people subscribing on YouTube. Loafbone, you and your gift subs. Oh my God, 97, seriously. Good Lord. But thank you. I appreciate it. That's very sweet of you. Oh my goodness. Now, Cyberfart, awesome name. Alexandro, Kriegersaurus Rex, Risky Banana, and Nsweep. You all have gift subs. Welcome. And Mr. Boolean, thank you for subscribing too. Thank you for using your Prime sub for me. I appreciate it. Thank you. Only 72 away from your goal. Oh my God. I thought you were going to stop when you hit 69, but now you want 169? Okay. All right. Well, whatever makes you happy. I'm not going to argue with it. And thank you, level 2 hype train. Sweet. We're going to get like cute little emotes, right? I'm excited for that. There's always like really funny ones that we end up getting. Okay. What else? All right. So one kind of distribution that we should talk about, obviously, is you'll hear like a normal distribution. And not normal as in like everything else is abnormal. This is in like the math word norm, meaning like mean or average. And so for your normal distribution, a couple of things to note. The center of this is going to be your mean. You're going to have your standard. Yay! Ask our Vidar. Thank you so much for the bits and the cute dog. Oh my goodness. And thank you, 300 bits. That's wonderful. So now we have 400, so 4 dog treats from Ian Alex Hart. And now we have 3 dog treats from Ask Our Vidar. So now we're up to 7 dog treats for the boys. Goodness. I'm going to blow through this next bit so that we can get to the dogs, because I think that's what people are asking me for. Standard deviation determines your height and width of your curve. So like a large standard deviation here would mean like a shorter but wider curve, and a smaller one would kind of be a narrower but taller curve. You can also have skew, and this is what I was talking about earlier. So I'm actually going to try to draw this. Bear with me. Loafbone! Oh my goodness, these dogs are going to have so many treats. Thank you for the bits. Now we've got 7 plus 4, 11 dogs. Oh my God, these poor dogs. They're not going to have like... So really quick, because this is important. All right. So this would be an example of negative skew. And the reason why you might care about something like this is, remember how I said with like a normal distribution. So let me try to draw like a normal distribution here. All right, well, that's an attempt. That's not maybe the best attempt, but I'm not an artist. So this is where our mean is, right? For our normal. And oh my goodness, a gift sub for Justice Good Joe. Thank you. Oh my goodness. Yay, Justice Good Joe, now you have a sub. And let's see, Professor Saucecat, you say when you started getting into machine learning and deep learning courses, you never thought that your geostatistics courses would be of help? Yeah, seriously. I didn't think astrophysics would be that much help, but especially when I started doing like computer vision and like machine learning for remote sensing, I was like, oh, this is the same. This is like the same stuff. But so look here, if I have a negative skew, I might kind of incorrectly be like, oh yeah, like this should be my mean, right? No. So your mean is still here. And that's what people, and your median's going to be like here. So the skew can really, really like drastically affect your measures of central tendency. And so it's important to, if you have that skew, one, be a lot more careful about like what model you're using, and understand how your model might use various measures of central tendency to determine like model parameters, and then also maybe have a plan for like how you're going to deal with the skew. Similarly, if it was like if this little like peak was kind of smooshed over and the tail was that going the other way, that would be a positively skewed. And Sontag, you ask, where am I from? I grew up all over, actually. I'm in the DC metro area now, so the capital of the US, but I grew up all over. One thing to note here, you might be like, oh, so just, if you've got skew, whatever, like get rid of these anomalies or something. But one place that you see skew come up a lot, and people who are interested in cybersecurity, this is kind of for you, or if like me, you do stuff with like disaster response or disaster relief, is that rare but like high impact, that's not how you spell that, rare, high impact, talking and writing at the same time, rare high impact events are going to be like, your data set for that will often be skewed, because this might be the thing that you're trying to account for. So in a lot of like risk analysis, you're going to have skew but you can't just like drop those things out of your data set to like make a normal distribution, because the outliers, those anomalies that might be causing this skew, are the things that you're trying to predict, or those are the things that you're trying to prepare for. So like maybe instead of impact, I'll say like importance. So like low incidence, high importance events, you're going to see that a lot. You're going to see highly skewed data sets, because that's kind of like the impact of like, say, hurricanes or like earthquakes, right? It's like the vast majority of earthquakes are smaller. They're not going to have that much impact. And then we're going to have these like super, super, super rare, infrequent events that cause massive, massive catastrophe. And yay! Thank you guys. We got a level 2 hype train. I want to see what my emote is. I got the one with the potions. I love that one. Yay! Thank you all. 7 subs, 900 bits. Okay, so 9, and then we also have the 2 from Ian Alex Hart from before. So 11 treats for the dogs. I'm almost through this. There's just 2 other things I want to talk about very briefly, and then we're going to do dog break, and then we're going to go on to the code. So stick with me, please. We will see dogs very soon. But also, I do want you guys to know this information. Okay, so the other thing that I want to talk about is something that we've talked about previously, which is, do you guys remember, those of you who are here for like streams, probably talked about it on day 1. So linear regression, any of the regression and classification streams, we probably talked about it, but I brought up something called multi-collinearity, which, right, is where you have multiple features that have a correlated linear relationship with each other. So if we're going to step back from that, right, and we could talk about covariance and correlation. So covariation is simply the variation of multiple variables together. So like they are varying in ways that are related to each other. And for those of you who are fans of the math, let's see. Strawberry Jesus, you ask, what are the common techniques to deal with skew, or it depends on the task? It depends on the task, unfortunately, because it really depends on what's causing the skew and what that data represents. So for example, I've had data sets where that's just like, there was like an error in the sensor. So like astronomy data, maybe like just some of our images ended up crappy quality. And that kind of thing, you can just drop that. You can just like cut some of those anomalies. But like I mentioned, in some data sets, like a cybersecurity data set, or some kind of financial risk modeling or disaster modeling, it might be that the things causing the skew are the things that you're interested in. And then it gets a lot more complicated. So it means that you have to there is an assumption in a lot of machine learning models that the input data has a normal distribution. And so when you know for a fact that your data doesn't have a normal distribution, like one that's going to affect your model, it might affect your model choice, but then it's going to make there's some kind of normalization or kind of data cleaning things that you can do, but it complicates things a lot. So the short answer is it depends a lot on what that skewed data is, what the anomalies that are causing the skew represent in your data set, what your kind of question or research priorities are, and then what kinds of models you're using. It's messy, but that's another kind of way that real data really throws those curveballs at you. Hi, Canis. Welcome back from a long time away. I'm glad you're here. So if we have two features that we're looking at, and just like when we were doing our machine learning stream, just that I've written an X doesn't mean it's a single value, right? This could be our feature, like a vector, for example. So like a whole, you could think of it like a one-dimensional array. You could think of it like a list of values. Each of these could be that. I'll do. You ask, will I upload the VOD on YouTube as well? And do I plan on covering data science more on future streams? Yes. So this is just the start of another series I'll be doing. God, I really need to find out who was here. What did I say on the Discord, or what did I say on Twitter? I need to remember what I called this. Fundamentals, I feel like is what I called it. I'm looking at my own Discord so I can remember what I named something. Fundamentals of data science is apparently what I've called it. And this will be it'll be another playlist on YouTube, just like the machine learning, the 12 days of machine learning myths. And so the just like with that, the VODs will be on YouTube. The code will be on GitHub, and the images of all of the notes will be on GitHub as well. So just like with machine learning myths, similar format, it'll be a different repo on GitHub, but it'll all be under either the same GitHub username, and it'll also be under the same YouTube username. So it should be pretty easy to find. I'm thinking about doing this series on Science Sundays. So I haven't decided if it'll be every Science Sunday, because I know a lot of you really like the astronomy streams as well. So I'm still kind of figuring out some of the details, but we'll work it out. Okay. So we had a sum. Remember, that just means sum. And let me write this out, and then I will tell you what this means. So don't panic too much. But so for covariation, what you're looking at, this means the mean, that little I know to those of you who do physics, that might look more like a vector, but this is just the average, our average x. So what you're looking at is for each x value and each y value we have, we're going to multiply by each other how they change. So and we're going to average it. So a positive covariation, right? Think about this here, is that when would we get a positive value? Well, we would get a positive value whenever x and y changed similarly with respect to their averages. So if a lot of our x values, for example, were below below the average and a lot of our X values were, or a lot of our Y values were above it, we wouldn't get as positive of a covariation. And like if they both were below or they both were above, so they're trending in a similar way with respect to their averages. They're varying in a similar way. They're covariing. Then you'll get a positive covariance. And yay! Oh my goodness, Ian, Alex Hart. Holy crap! Now we've got 21 treats for these dogs. I don't know. Loafbone, can you prep a Kong maybe? Maybe we need a Kong stuffed with peanut butter and treats. Like that might be what we need. We've got like 21 treats. We'll throw some from the Furbo, don't get me wrong, but like we're gonna need something hefty for that. Goodness, thank you so much for the bits. Oh my goodness. But this has a drawback, right? Can anyone think of some drawbacks? Like why this might be like, ooh, this could have a problem. Does anyone see what the problem might be? And while people are figuring that out, or no, I'm sharing my screen, so I will prep the dogs in a moment. And this is the last thing that we're doing before the dogs. And it's okay if you have no idea. I think though, think back to, it's going to take a similar kind of logic to when I was kind of explaining why we scale our data. It's kind of a similar problem there. And Aesop Shamrock, thank you so much for following. I'll give everyone a couple seconds to think about it. Why we might have trouble with covariation, why it might, maybe it's not ideal in a certain way, or maybe what case would you say like, ooh, this isn't helping us as much. So here's a hint, is that imagine that you're looking at the price of a car and the years since the car was made, like its year of purchase, and like that represents, instead of it being like 2006 or something, maybe it's like 3 years, because it's 3 years after the car was made, the car was bought. I don't know much about cars. Well, when you have values that differ, like the range of those values, the amounts of the differences between them vary a lot more, you're going to have like, what does a covariation of 10 mean versus a covariation of 20? Well, depending on your feature, like that could be, those actually might not indicate a massive difference in covariation, because, you know, a variation of 20 when it comes to $20 difference between the cost of cars, which is like, you know, $30,000, $40,000, isn't that much compared to maybe a difference of 5 years or something, which might be a lot more. And so this can be really hard to interpret, because if you have features that have different ranges, different, you know, extremes, the covariance can be difficult to interpret. So this can be difficult to compare amongst different features, or difficult to interpret. So one of the things that, and Pascal, thank you for following. One thing you can use is a correlation instead. And so a correlation is just going to normalize our covariance for us so that it becomes on a -1-to-1 scale. Correlation. So we're going to use our covariance. Okay? And then we're just going to divide this by our standard deviations. And so in this case, to interpret this, you're going to have -1 would be what we call an inverse correlation. 0 is no correlation. 1 is positive. Yes, sorry, I'm saying that wrong. Thank you, Strawberry Jesus. But so here's another question, and I think this one is maybe more intuitive, which is, when does this fail? Like, why is this just... A lot of people, I find that they overuse correlation. Correlation's great, don't get me wrong, but like, it's gonna miss some things. There's times when it's gonna fail. When can you imagine those times? So we're gonna draw some pictures, but when does correlation like, when might it say, oh, like these aren't correlated at all, but maybe they are. Like, correlation, like I said previously, is just one metric that you can use, one measurement, but just try to think about a time when correlation might not give us an expected result, or there might be relationships between our variables, but correlation is missing it. What might those types, or like what might those situations look like? And I'll draw some pictures to get people thinking. Oh no, we need sparkly. I'll use this sparkly data. A Bernie overlay? I don't know. Paranoid Polaroid? I didn't know there were. I haven't seen any Bernie overlays. Oh, you mean like with him in a chair? Yeah, I bet there's lots of those. I barely have time to like remember to update my stream. Like my stream title or my stream overlays, let alone add in cool stuff like that. I'm gonna do an H for Hubble. So we're gonna see the dogs in a second. So I think hopefully you're starting to kind of get what I'm getting at here, right? So yeah, Strawberry Jesus, correlation doesn't capture clusters. No, it doesn't capture, it can, just because you have a correlation coefficient or you have a correlation of 0 doesn't mean that there isn't a relationship between those two features. It's just not a linear one. So you can have, you can have no relationship, absolutely. But you can also have really complex relationships that correlation isn't going to capture. So something like this, absolutely, we're going to get, a positive correlation here, but it's going to miss out sometimes on other kinds of relationships that your features can have. So this is like a cautionary tale of like correlation's great, but like it is not the be all end all. Just because you have a really strong correlation or you have 0 correlation doesn't mean what you think it means. You need to investigate further. Okay, so I am going to get the dogs ready because I think we're ready for some pups. I don't know about you guys, but I'm ready for some dogs. So let me switch back here. Yes, oh my goodness, we're gonna have so many dog treats. Oh my gosh. It's gonna take just a second to get the like software thing up and running. So just give me a sec. I guess while I'm getting this ready, the other thing I had wanted to talk about was missing data, because I think, who said? The Gonzo, you said incomplete data. So missing data can cause a lot of problems. And when you're doing your EDA, you should look for cases of missing data and think about how you're going to tackle it. So some ways you can tackle it. You can drop data that's missing. So you can drop those instances, those rows, right? Or columns that have a lot of empty or missing or invalid values. You can try to fill those values. So it's common, fill them with zeros, fill them with a value that is so outside of the normal range of your features. You can fill them with an average, like a mean or a median. You can also use something that we'll probably do in a later stream, which is called imputation, which is essentially one of the ways that you can do this is that you can train your model on a smaller subset of the data, and then you can use that model to predict the missing values. So like, I did that once on I think it was like the Titanic data set or something. So it's a really straightforward process, and we can definitely take a look at it. Why is it in black and white? Loafbone, is the light on in the kitchen? Usually it does this when it's has night mode on or whatever. But it's weirdly black and white. And please enter valid username. We say, what if data Titanic has? So it's a really common Titanic data set. It's a very common data science data set. Oh, well, I don't know why it's black and white. Let me see if I can fix it. One sec. I turned night vision off, so maybe that will help. Let's see. It's reconnecting. Hold on. So yeah, please enter valid username. There we go. That was weird. It just thought it was nighttime. So hold please, friends. Okay. Give me one sec here. I'm just fixing a couple of things. There are some data sets that are very, very common for data science. And that is one of them. So it's one that I used previously on some of the machine learning Miss streams. And it's a good one to be familiar with. Okay, all right, enough of me blabbing. Because you want to see, why does it keep showing? Hold, please. It keeps showing the, it has all these weird views instead of just one view. So I don't know why it's doing that. It's very annoying. So give me 1 sec. I'm going to try to fix it. And then if I can't fix it, whatever, we'll deal with it. Usually it doesn't do this. So let me just shrink it down maybe. But yeah, so it's a good data set to know. Is it behaving? It is behaving. Okay, here you go, friends. Dog time. All right, so we have, oh God, we have 21 treats to give the dogs. So I'm just going to throw them out there and we're going to keep throwing it. I'm not even going to keep track. We're just going to give them a whole lot because they deserve a lot of treats. Let's see if we can get to Schweebs over. Hobble Bear. Here he comes. Here's a very good boy. Extremely excited that all of you are donating bits so he can have a butt ton of treats. What a good boy. And then it just crashed. Okay. We'll load the Furbo again. Come on, Furbo. And let's see. Yes. Please enter valid username. That is an excellent undergrad to have. I would say things to keep in mind for data science. Statistics, it's good to have knowledge of that. You do need, if you're going to go into more of the machine learning aspect of data science, you'll need calculus. So I don't know how far the math goes with statistics specifically, but also programming. So if you can get, even if it's a computer science minor or something like that, that will come in handy quite a bit. And yes, dogs, this is Hubble. This is my dog. He's a very good boy. And the bits that all of you so graciously donate to stream get converted into dog treats that he then gets. So he's a fan of stream because he gets lots and lots of treats. Oh my goodness, what a good boy. Oh, hold on, here you go. I'll keep giving you treats. So my other dog, Tennessee, often sings for all of you. So he gets very excited whenever I'm streaming. He's gotten to the point where he knows if I come out of my office and I've been streaming, he knows he's going to be singing. And so he gets so, so excited. And I know, A. Pascal, he's the sweetest boy. And thank you, Ian Alex Hart, for more bits. Oh my God, what are we at, 223? This dog is going to get so big. He's already a big boy. But he had a very long day yesterday at day camp. So he deserves all the treats. He deserves all the treats. Oh my goodness. I love him so much. And look at him, he's got, for once he's not limping. All of you poor people, for most of Machine Learning Miss, he had cut his paw, and then because he was limping on the paw that he had cut, he was, compensating with his other paw, so then he hurt his other paw, and it was just, it was this whole big drama with him. So he is all well. He is wonderful. And N-Sweep, you say, your pup is watching the stream intently. Just you wait, my friend. Just you wait, because when Tennessee sings, he howls. So I would love to see what your dog does when Ten sings. And Strix, no, there is a dispenser. So this is called a Furbo. It comes with an app, and then I'm using BlueStacks, which is a app, kind of simulates a mobile environment so that you can have apps up on your computer. So nope, he's going there and he's getting actual treats from this. So he's such a good boy. He's trying to do a lot of things. So later, maybe if he comes in and he sings too, sometimes he sings too. I can show off some of the tricks that he can do. But he's a very, very good boy. Oh, thank you so much for the bits. Yes. Okay, so we'll give him. Oh my god, I don't even know how many treats I've given him. Oh, he's such a good boy. I really want to see if I can get him to catch it. So his most recent favorite game is I got him this like soccer ball that's about this big, and although the game that he's learned to play is actually more like volleyball, he knows the word soccer. And so what it is he sits like a very good boy, and I toss the ball to him, and he jumps up and hits it with his nose back to me. So it's more like a volleyball volley, but still he knows it as soccer. And he just this is his favorite game. He gets so excited. I should just have a stream that's like this area, because he's often here. And as long as I'm not going in and out of the kitchen, it can just be like a casual dog stream. Yeah. I think there's some videos on Twitter of him playing soccer. Okay, we'll give him 5 more treats. Okay? I gotta be good. All right, so 4 more treats. You trained your cat to jump to touch your hand with her head to ask for food. That's so cute. One of my cats used to play fetch, and he knew his name, so he would come when I called him. So he was a very, very good cat. Look at him. I just love him so much. He's been sleeping most of today because he's quite tired. Oh, okay, there you go. I love his expectant look of please can I have treats? I'm a very good boy. All right, 2 more. Oh, that he got a double. Did you see that? That shot 2 treats for him. Little spoiled boy. He has another toy. So 1 more. He has another toy called Clever Pet, which, like the Furbo, it does dispense treats, but unlike the Furbo, it makes him work for it. So it's a series of lit pads where it trains him to use it, and it'll play different games with him. So it's gotten everything from Simon Says sequence matching, so it'll flash a sequence of lights and he has to put the same sequence back in, to color matching and all kinds of stuff. So all right, but I think it's time to code. So let's say farewell to Hubs. He's a very good boy. We might see him later at the end of stream, but he's been our nice break because we just did all of our notes, and now we'll get to coding. So give me 1 sec to set things up. And hi, Paper Stained Ink. Thank you. Thank you so much for stopping by. How are you doing? I hope all is well. Where did I put our notebook for today? Ooh, that made a chonky notebook. Hold on. And people liked, what was it, 150 zoom, I think? Yeah. Okie dokie. Just gonna get a few things set up here. Okay. And here we go. Okay. See, yeah, my green screen's being all weird. You can see the fuzziness. I don't know. It was being weird today. I'm sorry. And Starboy Jesus, you say, do dogs have short-term memory, bad short-term memory? I honestly don't. That's a good Loafbone question, honestly. So he's our resident animal expert. But I honestly don't know. And Paper Stained Ink, you say you're very sleepy, cozy in bed. Oh, I'm jealous. How am I? I'm good. I'm not the happiest that tomorrow is Monday. I think the weekend went it went by way too quickly. Oh, I'm just wait, Loafbone. Wait, no, last week was my 3-day weekend. Oh God, I just literally thought maybe tomorrow was last week was the 3-day weekend. Okay, well, just give me a second to have my heart broken, and then we'll get back to coding. Oh, man. I was like... Okay. I just like... I don't know why. 5 days of work just... By the time the weekend happens, I need one whole day to like rest and recover. And then Sundays, especially now that we're doing these more like prepped streams, I have to spend like I spent from probably like 3 to maybe 4, 3 to 4-ish around there, all the way through 7 prepping for this stream. So I feel like I want one more day off. Like I want to work 4-day weeks, but, and low fun. Did you just make a reinforcement learning joke? You say it's not amazing, depends on the reinforcement that you apply to the learning. Hey! I'm guessing that's not actually a machine learning joke, but I'm going to take it that way. Okay. So like I said, tonight we're going to be working with some... Let's just get this all set up. So we're going to be working with some happiness data. Oh, thank you, Generic Crew. I hope you have a good night. Get some good sleep. Rest is important. And despite me saying that every single night, I'm up way too late because I'm like, oh, but I just don't want to go to bed yet. And then it's like, you're so much happier and you have better days when you go to bed on time. But I'm still somehow like a child in my mind and I have no self-control. So I have done nothing to this data so far. I've just set some parameters for like font size and stuff for our visualization library. And I've just read in the data. So we've got data from 2015 through 2019, all related to happiness score. So actually, I'm going to just resize this a little bit. Because this is, I need to be able to reach the bottom. All right. But I don't want to zoom the whole screen because then it looks weird. Yeah, I think that should do. Okay. So, everyone's like, that's you every night. I know, what is it? I don't know what it is. It's like, so I read a study that said that people who feel like they don't have control over their day often will stay up too late because you're like, this is, at least I can control my nights. I don't know if that's the reason for me or if it's like an ADHD thing plus like being a little bit of a night owl where I'm not like a hardcore night owl, but like I definitely reach, like I get a second wind at around like 10 p.m. and I seem to be happy going to bed around midnight, waking up around 9. I do pretty well with that. But even then, like there's definitely nights. I have this sleep app that it's exploratory data analysis of my sleep has some sass because it's like, I keep getting these alerts. It's the Sleep as Android app for anyone who is interested. And it'll be like, where is it? Let's go like irregularity. So like it's very grumpy at me for like my sleep irregularity. So this is like how much when I go to sleep and how long I sleep differs. And you can also see like this is how long I sleep. So it's like I'm either sleeping for 11 hours or I'm sleeping for like 4 hours and just rarely in between. So it's always like up and down and up and down. Anyway, sleep's great. I don't get enough of it. I love sleep. Anyway, okay. And Kriegersaurus Rex, you say, having worked afternoon shifts, your second one happens at midnight or 1 a.m. I used to be more like that. And as I've gotten older, I'd say it's shifted a little bit earlier, but not like so many people I know go to bed at like 9. I'm just like, oh, hell no. Like I get the second one around like 10 to 11 and I want to be up till like, I think when I'm left to my own devices, I get really tired around like 1 or 2. And then I want to sleep until like 11, which is not always feasible, 10 or 11. So like my sort of I'm being productive happy place is going to bed like midnight, waking up around 9. But I'm not getting old. Don't tell me that. No. I know I'm getting old. Sitting here like complaining about my back problems and also saying I want to go to bed earlier. No. Okay. So these are a series of, like I said, these are a series of data sets related to like a happiness score. All I did here was I read it in with Pandas library and I set the index column to be the country. And the reason why it changed, and this is something we're going to look at, is that the 2018 and 2019 studies did different things. So one thing to look at whenever you have data that is spanning different years like this, and it's clear that like it's in different files, especially if those are data sets that are generated from like a study or a census or a survey of some kind, is like to look at what they measured. So here, this is the one that we have up here in 2015. We have a region, we have happiness rank, happiness score, a standard error, economy, family, health/life expectancy, freedom, trust/ government corruption, generosity, and dystopia residual. But then if we compare this to like 2019, we're missing a lot more. They're labeled differently. And what was the other one that was like weird? I think it was like 2017. And this one is like just, it's got like, you know, periods here. It's got whisker high, whisker low for like a whisker plot or for a box plot. But so this is the kind of thing to immediately look at from like a data cleaning and EDA perspective, is like the naive sort of, naive there I don't mean as in like, oh, ignorant. I mean like the initial sort of like uninformed way that, you know, I would also try to go about this without knowing would be, oh, let's just merge all these into one big data frame, right? Well, you know, they have different columns. They're measuring different things. They have different labels. So it's a little bit, we're not going to be able to just smush these all together. So we can focus for now for 2015, just to like take a look. One of the things that you can do with pandas that is really, really nice is, why is it so random? Welcome to human beings. Like, I can't tell you, one of the clients I worked for collected data probably every 6 months on average, and every single time they collected it, they collected different values. They named their columns different things because different people would be manually entering the data. It was a nightmare. So this is actually way, way, way more common than you think. Okay, but if we were to look at 2015 and look at our happiness score, we can sort our values and just look at, I don't know, like the top 10. Oh, that is certainly your top 5, whatever. That is certainly a conversation, Strawberry Jesus, that I have had, okay? Trust me, I've had that conversation with them. And Icy Yogi, no worries. Thank you so much for the compliment. Get some sleep, okay? Thank you so much for stopping by. And Pale Blue Zebra, you bring up something excellent. And this was my own mistake. So here's learn from me. I was also rushing before stream to try to like at least get some stuff for us to work through. So like health life expectancy. I can't tell you, like it was embarrassing how long. I just read this as like maybe like a year. So like this is like the average is like probably 94 or something. Don't ask me why that got stuck in my head. But in fact, spoiler here, is that these are feature weights almost. So this is how much each of these various things, generosity, freedom, health, contributed to the happiness rank or the happiness score. So like, this is the weirdness of this data set, is at first I was looking at it like this is amount, and you kind of can see it as amount, but it's more like a fraction of a whole. But then, yeah, right? It's not normalized. I know, Strawberry Jesus, that's what I thought too. And this is also, when you get your data sets off Kaggle, read. I mean, I read through the description of it, but I didn't read the column descriptions, because a lot of times I'll skim the column names and be like, oh, this is like intuitive. Like, I know what this, be better than me. Read the descriptions, because I am Scoots. Thank you for following. Yeah, it's strange, but we can still look at things. We can still look at like at trends, and we can still do some statistics on this. So we're gonna forge ahead, nevertheless. It's kind of like feature vectors, but it was like, here, I'll show you. Hold on. Because I still have the link up in case I forgot what a particular variable was. So this is the data set, if anyone is interested. It is the World Happiness Report. And so let's see. Ranks 155 countries by their happiness levels. It's UN. Okay. Blah, blah, blah. This is great. It's effective. That's cool. Content. So it says the happiness scores and rankings use data from the Gallup World Poll. The scores are based on answers to the main life evaluation question asked in the poll. This question, known as the Cantril ladder, asks respondents to think of a ladder with the best possible life for them being 10 and the worst possible life being a 0 and rate their own current lives on that scale. The scores are from nationally representative samples for these years and use Gallup weights to make the estimates representative. The columns following the happiness score estimate the extent to which each of the 6 factors, economic production, social support, life expectancy, freedom, absence of corruption, generosity, contribute to making life evaluations higher in each country than they are in dystopia, a hypothetical country that has values equal to the world's lowest national averages for each of the 6 factors. They have no impact on the total score reported for each country, but they do explain why some countries rank higher than others. So it's interesting. It's not an intuitive way of having, it was the UN, Strawberry Jesus. So it's unexpected. And so this is also why things like data dictionaries are so important, because not just having, this is what, it's your happiness score. Okay. What's the range of this variable? How is it measured? What are the units? What's the error? Those kinds of things are really, really important, and a very good data dictionary, of which I see very few, would have those kinds of things. Maybe someone needs to write them an email. Somebody who has more time and energy than me. Okay. All right. So we're gonna sort ahead, because this is the data that we're working with, and it's, especially if you are working as a data scientist, a lot of times, most of the time, you're not going to just be able to go, wow, this data is shit, let's go get some more, let's get different data. A lot of times you're still stuck dealing with that data. So, alas. But okay, so we also have this column that is region. And so this is dividing the world up. So I wanted to see, my thought process here was what's the distribution across the world? And so you can see we have, and this kind of makes sense, is we would have the most countries from sub-Saharan Africa, then Central and Eastern Europe, Latin America and the Caribbean, Western Europe. This makes a little bit more sense because North America, for example, has a lot less a country density by continent than, say, Africa or Europe. So this makes sense, but this is also what I'm talking about when I say looking at, this would be a categorical variable, right? And you're looking at the distribution of a categorical variable. Okay, so one of the cool things that pandas can do for you is you can use the awesome describe method. This is just, for me, it's almost like a reality check, a quick do I have, this is where I will see any glaring problems right off the bat. So this is one of the first things I often do when I'm dealing with, if your data set is the type that can be imported into pandas, for example. So count here, this can be a great place to notice if you have missing data. So if these numbers are differing, then you have missing data. And so that can be like a red flag. Can anyone see maybe another red flag? Yup, Strawberry Jesus. I know, yeah, so Kriegersaurus Rex, I'm trying to not say that because I feel like it's got ableist sort of implications. So I was trying to find another good phrase to use instead of that, honestly. It's a good litmus check, kind of a good or litmus test, quality check, a good initial sort of are there massive problems here? So there's some red flags here, my friends. Count tells us we have no missing data, but what might be some problems that you see here? So I thought this was kind of interesting. Zeros. Yes, I am Scoots. Welcome. And yes, you are absolutely right. So this right here is a potential problem. Because while we have, it says 158 values. Great, isn't it? We're done. We can walk away. We have all of our data. No. because it looks like they've potentially, like there is no country that has a 0 in their GDP per capita. So this is telling us, there are missing values, they're just hiding. And so one of the things we can look at is like for life expectancy, for example, like no country is going to have a life expectancy of 0. That makes no sense. So we can look and we can index by, we can index our data frame with, expectancy. We can do Boolean indexing, and we can just set this filter here and say, where the hell are we claiming that it's 0? And so it looks like Sierra Leone has missing data for life expectancy. And this is also, well, I'm making the same mistake I did before. So hold on. Because this could be one of 3 problems, right? I'm making the same intuition I did last time, which is nobody has a life expectancy of 0, but that's not what these variables mean, right? So this is actually exactly where I went in and I was like, the hell is going on here? Is this missing data? And that's when I discovered, wait, these are variable weights. They are not values, like intrinsic values. So what this could mean is that they were missing data. It could mean that they were filling in a nan with a 0. It could also mean that this is accurate. And when it came to calculating Sierra Leone's happiness score, life expectancy did not contribute at all. So this is the trouble, right? This data is sneaky. And these are the kinds of things you have to catch, because you more so than anything, it's less like, let's make some pretty graphs and walk away, right? We need to be catching the red flags and going, wait. Like, we've got our detective hats on. What the hell is going on here? This doesn't make any sense at all. So this is actually exactly where I went. I'm not understanding these variables. Hold on. This doesn't make any sense. I went back and reread the descriptions and I was like, oh, wow, this is weird. I wonder if we can drive the level of competence of people doing this changing from year to year. Or, so we can sit here and we can just say, wow, this data is awful. I'm not going to be able to do anything with it. Or we can either make assumptions, and it's okay to make assumptions. You just need to document your assumptions. But like, if the happiness score, so what does this mean? Does this mean that the only thing they asked the people was rate your happiness? Or did they ask them also, like, what do you feel like how important is family to you? How important is like health or something? Did they ask that? And we just don't have the raw data? Or is this telling us like life expectancy / health is kind of almost like a global average, so it didn't contribute as much to their happiness versus something that's more extreme? We don't know. This is the difficult thing. So it's another reason that, at least for me, I stopped dealing with the features as much, because we have one piece of reliable data in this, one piece that is raw, actual measured data, and that is our happiness score. So this is where, at least for me, I took a little bit of a pivot, and I was like, you can even see, so like, I went in and I was like, sorry, hold on, DF 15. No, that's not what I wanted. I wanted this. What am I even doing? And I was like, wait. This makes no sense. What the hell is going on here? So yeah. They don't have, no, they don't Strawberry Jesus. The explanation literally is what I showed you here. So if you go down here, it's a metric measured in okay, so happiness, no, that's happiness score. So hold on, where is it? The extent to which GDP contributes to the calculation of happiness score, the extent to which family contributes, except that's not true. Like it says, describe the extent to which these factors contribute. But that's something they predicted. That's not like an actual measured value. This is like, it's kind of like, you remember in school when people told you to like use primary sources and don't use secondary sources? This is like not even a secondary source. This is like a tertiary source, right? So it's misleading. And so at least for me, oh, they're not even the 0-1 range. I know. Like, this was a nightmare. And then this is also where I was just like, what the hell is going on with this? Oops, it's not called that, is it? I'm a doofus face. It is happiness score. So I dealt mostly with happiness score because I was like, at least this I know is a measured value. And I understand what it measured. I understand that it's on a 0 to 10 scale or on a 1 to 10 scale, with 10 being the most. And it's a self-reported average population sampled happiness. Like, it's a survey result. So like, okay, I understand the measurement. I understand the range. I understand what this number means. Like, so I stuck mostly with happiness score, but I will show you some techniques, nevertheless, that you can use with other data sets. So this is our average. This is our average happiness score. You can also, I was curious how the happiness score average would change. And so that's good. It's going up a little bit. And hi, Chris does DNA 2018. You say you're just jumping into the channel. What's the goal and question? And also about 9 waffles, you say just tuned in. So this is part of a series of streams / videos, if folks are coming from YouTube, that I'm starting called The Fundamentals of Data Science. And so I just actually finished a series of streams called The 12 Days of Machine Learning Myths. And one common question I got during those streams was, because I used a lot of like pre-cleaned, pre-prepared data so that we could focus on the models and the math. People were asking, well, how do I get like real data? How do I prepare it? How do I explore it and know how to prepare it for a model? So this is the stream that resulted from that. And I realized that a lot of the questions I got during those streams were really about the fundamentals of data science. So today we're just talking about exploratory data analysis. The first 2 hours of stream was mostly like more conceptual. So we went through some discussion of like what EDA is, you know, things to look for, tests and statistics that you can use, the data science process, where EDA fits in the data science process. And now we are exploring with code. And so this particular data set is available from United Nations. It's the results of their yearly World Happiness Report. And really, I'm just trying to show everything that we talked about for the first 2 hours. So how to investigate the data, how to do exploratory data analysis. Don't worry if you missed those previous 2 hours and you're like, oh man, like I wanna know everything. Videos go up on YouTube. The code and the notes go up on GitHub. Same with everything from Machine Learning Myths. So all the videos are up, all the code, all the notebooks, all of the, you know, whiteboard images and everything is all up on GitHub and YouTube. So, okay, what we just discovered though, which is something I discovered right before stream started, is that this is a really weird data set. And so unlike an ideal data set where, you know, it's measured values that, or you know, even if it's categories, like these are things that are measured, they're reflecting actual reality. This seems to be a very strange data set where the only actually measured value is the happiness score. And the rest of it seems to be like a model that they made, or like all they say is that this is how much this particular factor of life contributed to the score. But it's not something that they polled the population on. It's like, I think, their own prescriptive judgment on how much those things influenced the score. So there's no documentation, at least on the Kaggle documentation for how they calculated this. I didn't have time to grab like the report itself, read it, and see if there's more information. IRL, if I was like working with this data set for work, that would be my first step, is I would actually go to the UN, download these reports, read them myself to get more context. But this is, yeah, I didn't know if it was like, maybe, but some of it just doesn't seem realistic to me. Like, you're telling me that life expectancy and health had zero impact on the happiness score in sub-Saharan Africa. Like Sierra Leone, where like, wasn't there, this is 2015. I forget when when was it? It was totally the last 5 years. There was a major outbreak of Ebola in Sierra Leone, wasn't there? Am I just like, no, I'm like 75% sure I'm remembering this correctly. So like health definitely impacts people's happiness. Like the fact that that is 0 tells me something. 2014. Okay, so the year before this poll was done. And you're telling me health and life expectancy have 0 impact on their happiness score? Like, I'm going to call bullshit. Like that to me, this is raising red flags for me about the trustworthiness of the data. So regardless of where these various metrics came from, I don't trust them. I mean, I would have to read the report, go through, see how they came up with them. But this seems really weird to me. And like maybe I'm totally wrong, but like it's important. I've worked with enough data at this point and enough health data that like you also kind of learn to trust your intuition. Like a lot of times when you get that feeling of just like something's not adding up, this data just doesn't seem right. There's a lot of gaps, there's unanswered questions, like trust your gut. And Diraj, thank you so much. I will hydrate. Okay, so nevertheless, though, we have identified some red flags. We've identified some problems, but that's okay. I'm going to show you some cool stuff that you can use either in Seaborn or Pandas or Matplotlib that are great tools to do in your exploratory data analysis, while we also are keeping in mind in the back of our heads that, like, we're not so sure about this data. Strawberry Jesus, you say maybe it's like descriptive metric of how much health, life expectancy, quality-wise a certain country got. Well, that's the thing, is that the UN's own description of it is how much that particular factor contributed to that country's score. So by their own definition, what they're saying is that for Sierra Leone's happiness score, health and life expectancy did not contribute at all. So I'm going off their own definition. So either they defined it terribly, which they did, or it could be missing data, absolutely. But then how do you have missing data when all of these seem to be like we were talking about, are these regression coefficients? How are they getting this? This is how much this contributed, if not fitting a model to this somehow. How do you prescriptively get these numbers? And it's not like a ranking. So these aren't like these aren't integer values, right? We have irrational numbers here. So these are things that are calculated. They're not just like ranking these things, these features of a country or something. So there's a lot that's not adding up, and that's making me a little bit suspicious. But nevertheless, one of the things that you can start to do, and this is something that I talked about earlier, is that while kind of in your textbook or in your, boot camp or whatever, they're going to tell you, you clean your data and then you do your EDA. I would say 100% of the time, honestly. For me, I do those things concurrently. So as I'm exploring the data, as I'm doing the visualizations, or I'm doing like some statistics on it, or I'm just investigating things, I'm also kind of noting things that will need to be cleaned. Where is Australia ranked on this? So I have, crap, I said that as the index. Hold on. Index. So let's see. Oh, Australia's in the top 10. So Australia, here you go, is ranked 10th. So there you go, Gussie. Not so bad, right? And you often, so I am Scoots, there are some things that you can note immediately, like misspellings, or like we just noted, columns are named different things across different years. But a lot of times, it's not until you start trying to mess with it that you're like, So one of the things that you can note when you're looking at your data set is, are there things that are redundant, so that we can start to narrow things. A lot of times when I start out with a data set, I can have hundreds, if not thousands of features. And so immediately, to avoid complexity, like overly complicating a model and often overfitting your model, you should also be thinking about like paring down your features. So here, one thing that I thought of, we consider clustering by this maybe, but for at least the purposes of tonight, region is duplicative information. So it's a categorical variable that we would have to encode or handle in some way. And it's not really telling us, We're not going to be doing any kind of geographical analysis. So, you know, one of the things that we can do here is we could just drop it to make things a little bit simpler. So it's quite easy to drop stuff in pandas. Don't do what I'm about to do, which is take it from me. I'm gonna like show you what not to do, which is to do it in place. Don't do that. Rename it something else, because I can't tell you how many times I'm like, it's fine, I'll do it in place, I know what I'm doing, and then I screw up something later doing it in place, and like you have to go all the way back. So it's helpful to not do it in place and instead have like, by not doing it in place and actually making new variable names for your data frame at different stages of your cleaning or your EDA, they're almost like save points in a video game, where if you screw up something later on, you can just go back and start from that point versus having to start from the beginning. But I know this works, and for the sake of stream and not having to type things a lot, I'm going to do it in place. Don't be like me. Be better than me. And so while we know also that these maybe aren't the most helpful features, I still want to show you something that could be really helpful. If you're a numbers person, you don't have to do the heat map, but a lot of people are more visual. So it can be helpful to visualize Panda's core method. And so this gives you a matrix of the correlation coefficients for all of your features. Also just a warning that if you have a lot of features, this thing can get really chonky really fast. So be aware of that. But what do we see here? So we see a happiness score having positive correlation coefficients with economy, who'da thunk, family, health and life expectancy, things that we would kind of, that feel intuitive. Same with like economy and health having a positive correlation coefficient. If you are more of like the numbers person, a lot of times I use both. I use this to just do a quick skim to notice anything that like jumps out to me, and then I follow up with a more detailed analysis of the numbers themselves. But it's a really, really, really helpful method. Another thing that can be really helpful is Seaborn has a pair plot method that you can use as well. And this will take a second. So especially though, if you have more features in your data, don't just pair plot all of them. But this is essentially taking like the core, just what core did here, but it's going to show us like a visual representation. It's going to plot each of these against each other, as well as showing us when it plots one column against itself, it'll show us the distribution instead. And thank you, Ian Alex Hart, for the bits. Thank you for the cheer. So you can see though, we don't have a lot of features, and already it's like, whoo, gracious, like there's a lot of plots. But again, not only can we remember what I told you about correlation coefficients being sometimes misleading, but it's a great way to skim and just kind of see immediately if there are patterns in your data. And let's see, Yassine 10K, you say, what is the difference between this data and the data of Titanic and Kaggle? Well, they're just different data sets. So the Titanic data set on Kaggle is a data set of the Titanic survivors and various characteristics. This is happiness score from the UN. So they're just different data sets. Can we do a quick preview run? Preview run of what? And hi, C Films. Hi. How are you doing? You say your week is going great? My week hasn't started yet. It starts tomorrow. So this is the last day of my weekend. Heartbreak. Hi, Katya Zeros. I'm so glad you were able to stop by. This is a great stream, I think, for you. I think you would really enjoy this. And so, you mean for this particular visualization and 05? So this is Seaborn's pair plot. What this is doing is it's doing a scatter plot of each variable against every other variable. So kind of similar to this correlation matrix that we looked at. And then when plotting against itself, it just shows us the distribution of that feature. And I know Kachi Zeros, I thought this would be so good. So I'm glad you're tuning in, because I was like, I really hope Kachi Zeros shows up, because you're talking about working with pandas and like kind of learning this stuff. So I thought it would be awesome to have you here. And so this is super, super helpful though, because not only is it like an immediate, just like bird's eye view of relationships in your data, but you can also see, like what I was talking about earlier, that remember that a correlation coefficient of 0 doesn't necessarily mean that there's no relationship between those two features. It means that there is not a linear like correlation between those two features. And so we should have learned already, for those of you who are at Machine Learning Miss, that just because there's not a linear relationship doesn't mean that there's no relationship. And that's a really common mistake that I see people making, is they do this correlation matrix and they're like, oh, I've got a value of 0 between generosity and economy, so there's no relationship. No, there's no linear correlation between these two variables. It doesn't mean that they're not related in some other way. And so that's why I really like not just doing the correlation matrix, but also following it up, if possible, with a pair plot, because this allows you to kind of get that bird's eye view of like the feature landscape and the relationships. And you can see that we have like lots of nonlinear relationships. This is where you'll see things like clusters. You can start to think back to our unsupervised learning streams that we did. And also when I mentioned that clustering can be a way to pre-process your data. So you can notice that there's like those similar kinds of concepts that we think about, like density and like neighborhoods and stuff, that we might see more complex relationships. So like, let's see here, like generosity and family. Like this is not a perfectly random association here. Like we have some clustering and we have outliers. So don't just let your correlation coefficient be the be all end all. And about 9 waffles, thank you for following. Let's see, you say, got any sweet algorithms to show us? So tonight we're focused on EDA, exploratory data analysis, but definitely I think this is the new series that I'm working on, and so we will definitely go into models and different algorithm approaches, because it's going to be part of, like, I don't know, fundamentals of data science. I can make it whatever I think is a fundamental is going to be a fundamental. So if there are specific topics, though, people are interested in that we didn't cover in the 12 Days of Machine Learning Miss, let me know. I'll add it to the list. And C-Films, you say, you started studying Python, you're learning how to make a calculator. Oh, cool. That sounds like fun. And NSweep, oh, I'm so glad you're liking this stream. You say you're starting an immersive data science program in a week and you're looking forward to the rest of the series. I'm so glad. I'm excited that you're in an immersive program. Those kinds of programs and boot camps and stuff are great. So when you hear me, by the way, this is something I will say a lot, is that I give cautionary tales about like those kinds of shorter programs or 24-week boot camps or whatever. That is not a criticism necessarily. Like, that doesn't mean they don't have value, but hopefully I can also kind of give you the a little bit of like the cautionary tale, because I think a lot of people walk away from some of those programs and like they know a lot, and that's great, but they're kind of ill prepared to immediately start as a data scientist. And so at least for me, I'm hoping that maybe these streams can fill in some gaps, or they can give kind of like a preview into what the actual work looks like. But if you do have questions, or like I said, you have topics that you want me to dive into, just let me know. Gussie, you say that you love Python. I'm so glad. I love Python too. I'm falling more and more in love with C#, to be honest, because it has like, I don't know, the static typing and like just explicitness that I really loved in C, with like the object oriented and like readability and flexibility of Python. At least so for me, I'm loving Python, but it's kind of like I've got a new crush. Like, sorry, Python. Like, I was dating Python for many, many years, but now I've got a new flame. I've got a new bae. And no, I love Julia too. So Professor Saucecat, I actually started learning Julia for a work project. and it was brilliant and I loved it. I didn't get enough chance to use it though, so like I got Julia's number. Like, I'll be following up. But and then Don't Drink and Drive, where you say my new bait is C#. So but that's like, okay, and Krieger Source Rex says it beautifully. That's the thing about programming languages, is they're tools, they're different tools for different reasons. So like, you love them because they're good at a thing. And it's not like I like C# because it's better than Python. I just like learning new programming languages. And there's wonderful things that C# can do that Python can't. But that's fine because I use C# for different things than I use Python for. So, in any case, and let's see, Kachi Zeros, you say, that's why you're taking your time and studying about 4 to 6 hours a day. Holy crap. But taking your time, good, yes. Because at least for me, like, I've enjoyed taking like formal classes, and that accountability does help. But sometimes it makes me sloppy. Because when I'm like working for an A, I treat something very, very differently than when I'm working to understand it, because understanding does not always equal performance on a test. So if I'm like being tested and I feel like I have to get an A or something, my focus is on performance. My focus is not on like retention and understanding. And it sucks, but like that's a shitty thing about a lot of modern education systems, is those things are different. Whereas when I'm studying for myself, I might be slower, but like I deep dive and I retain it and I'm more interested in it. So, in any case, all right, so let's see here. I have an interview. I have a couple interviews with companies that I really like. And so I've been doing just like the standard, tech interview prep of like dusting off like your data structures and algorithms notes and being like, fine, even though I've never freaking had to build a circularly doubly linked list, like, let's go back and do it again and make sure, like, I remember all this crap. Ugh. Anyway, so I've been doing that for a couple hours every day of just, like, this textbook is let me show you all this. You'll appreciate it. And then we'll get back to this. But, oh my god, it's so heavy. Ugh, okay. Look at this chonky boy. Like, it's a great textbook, don't get me wrong. This is a chonky friend. Ugh. I mean, I got a thing for textbooks. I like textbooks. But this one is like, do you really need like so many freaking things on like binary search trees and like, good Christ. Oh, wonderful. And like the review, so I just signed myself up for a class because I was like, fine, like, if I pay money for it, like, I'll be more motivated and it'll be a good review. The first freaking week, it's like, read 8 chapters of this. And I'm like, excuse me? It's like the driest textbook I've read in a long time. It's like, oh, just read 8 chapters of it. I'm like, oh, great. All right. Okie doke. It is a chonk. And Gussie, so, applying just data science, mostly like machine learning oriented data science. So I found the hard way that data science is such a broad field that it can be everything from like build us a dashboard and just like make our data look nice, all the way through what I more enjoy, which is like if software development and machine learning engineering had a baby. So Strawberry Jesus, they shouldn't. You ask, do they ask a lot of algo questions in data science interviews? I don't think they should. I mean, you should ask algorithm questions, but the algorithm questions you should be asking are machine learning algorithms. But unfortunately, yes. And a lot of places have like timed coding tests that are very much like that kind of leak code. Like, I don't do well on those kinds of tests because they're just so, it reminds me of really bad physics tests where it's like, consider this like sphere, and you're like, what the fuck does this even mean? And then somebody gives me the exact same problem, but it's like a planet in a solar system or something, and I'm like, oh, I know how to do this. This is really easy. But when it's this very like artificial, sterile, abstract, I struggle with that for some reason. It just like doesn't work with my brain. Also, I don't do time tests. Like, I'm very bad at those. So oh, Strawberry Jesus, exactly. I had a rant on Twitter about that. I was really cranky. It's like not happy at all. Okay, so let's see here. I am going to copy some code that I wrote earlier. This is nothing super, super fancy. I'm just renaming some columns so that we can extract the happiness score from each of these years and we can compare it. Because, I mean, all the other stuff is not very helpful, as we found out. So, happiness now. Oh, let me set my columns. Hold on. Normally, I do like to take you through every step, but this is literally I'm renaming, I'm extracting the happiness score, and I'm making a new data frame, just so that we can look at for each country their happiness scores for the last 5 years. And Ujtua, have a good night. I'm so glad that I've motivated you to go study. It seemed like, so I did do some co-studying, co-working streams, and I did one of those, and people seemed to like it. So if you do need motivation studying and you want to co-study or co-work, I'm hoping to do some more of those streams because that was fun. And C-Films, you ask if any of the data I look at or any data jobs I look at are heavy in Excel. The ones that I've enjoyed the least, yes. So that's it. I'm just to be perfectly honest, a lot of times if somebody's sending me an Excel spreadsheet, I'm often working with clients that are less data oriented and I've had less of a good time versus stuff that's extracted from a database, or I've been working a lot with stuff that brings me a little bit closer to astronomy. So a lot more imagery and GIS stuff and remote sensing. SQL's used a lot. I don't tend to use it as much for myself, in my projects, but I've definitely been on projects where it's used. Here's the thing about SQL is that, and I try to explain this in interviews, I'm if you need me to use SQL, just give me a week, if that. It's very straightforward and easy to learn. I have learned it in a week before, been fine and proficient on projects in it, and then promptly forgotten it because I didn't use it for 3 years. So I'm not calling myself a SQL expert, but if you need to pick it up again, it's not hard. Okay. Let's see here. Okay. And yeah, so Gussie, you say you learned SQL on the job as well. You're asking the database for information. And especially if you've worked a lot in Excel, similar syntax, similar principles, it's really simple. It really is. If you've never learned a programming language before, that might be it might be a little bit of a challenge. But that's something about being in the sort of or having been for years in the consultant data science world is that I get put on projects where they're everything is in some proprietary language, or it's in, it's using some software I've never used before. And I'm okay, well, given that most of these contracts anyway take a month to get spun up, 2 weeks to a month, just give me that time and I can teach myself whatever it is I need to know. I taught myself entire programming languages in that time to be okay, this isn't a language I haven't used before. Time to just study up, practice, and then I'll be proficient by the time this gets kicked off. So it's also when I'm getting interviewed for jobs and they're well, what about this particular library of or this method in this library for this language? And I'm look, are you here because you want an encyclopedia, or are you here because you want an independent creative thinker who can lead teams and build you cool shit? If I have forgotten pandas syntax. And I have used pandas so many times. Google exists for a reason. Do you want to hire the Google search engine, or do you want to hire a human being? Make up your mind. But anyway, that is a little bit of a ramble. Okay, so now, ew, that's ugly. Why did I keep that? That's a terrible plot. I don't want to do that. Oh, that's because that was me dicking around trying to figure it out. Oh, let's get this started because this will take a second. I tried to make this look nicer, by the way, before stream. I'm not a data visualization person, So I'm sure, like, I wanted to do this, like, nice, cool, like, trend line stacked plot. And then I remembered how much I hate visualizations. So, sorry, you don't get that. But what we do get is, in a minute, we're going to get all of the trends for each of the countries, and we can look at them. What is Pandas? Pandas, Nilesh, is it's a excellent library in Python for kind of data analysis and some basic data visualization. So it's what we're using right now to kind of look at our data and to do some of like the correlation matrix and things like that are all done in Pandas. And Kangaroo12, thank you for following. And yay! Yes, you say you finally caught me while I'm streaming. I'm here. I had to take like 2 weeks off because I hurt my back, and sitting is the thing that hurts my back the most. So I had to take a break, but I am back. And yes, I am Scoots. You're right. You say once you learn one language and how to think algorithmically, you learn new languages pretty easily. Exactly. And don't drink and drive, bro. I told you to say the opposite. You said, I thought you told us to always say that we're data visualization experts. No, say the opposite. Because data visualization, dashboard creation is something people love, especially like, I don't know, if you need a job badly, say that you're good at it. Like, obviously be good at it and whatever. But like, they will pigeonhole you fast in that. So at least for me, I'm also bad at it. I can do it. I can do it if I'm forced to. I'm not a visualizations person at all. I appreciate good data visualizations. Absolutely. Like, it's not for me though. I'm very bad at it. And Katya, of course. So I can explain the for loop. So the initial part of this for loop is basically saying, so you could do a couple different ways. So there's a way you can use Pandas built-in iter rows, which is a way to iterate across rows. If you're lazy like me, you can just say for I in the range that is the length of this whole data frame. So happiness is our data frame. Essentially, your length is just the number of rows. I'm going to tell it plot the row. So for each row, that's just going to be, we've got 5 columns. And iloc is Pandas integer indexing. So I'm feeding it the integer. So 0 would be the 0th row. 1 would be the first row. Then I'm setting the title because Pandas, I set the country as the index of this data frame. So at the same time, it's setting the title to be the corresponding index, and then show just makes it, instead of stacking all of those lines on top of each other, which would be really hard to see, it shows them as individuals. And exactly, I don't want it to become my job. I just don't like, I've spent too many days, if not weeks, of my life in my current job tweaking fonts and colors for things, and it has made me miserable. And there's beautiful human beings out there who love it and love diving into like color palettes and shapes and making things look beautiful. I really don't. That stuff makes me angry. Like, I just hate it. Like, I don't want to sit here and figure out how to change this line width. I just don't. I don't know why, like, my brain rebels. So it's not for me. This is why, though, whenever I am putting together a team of people, I always have there being one of those genius people that's very good at it. So, in any case, this is what was surprising to me, right? So remember how I told you this earlier, that I expected probably that happiness would be increasing in the top countries. In fact, we see the opposite. Except, okay, good job, Denmark. Denmark's like, hell yeah, Denmark's doing great. Norway's doing great, but like the top 2 were just like, nope. So I thought this was interesting to just like look at some of the trends. In particular, I thought Canada was really interesting. So I was curious about this because Canada went from being in the top 5 to barely making it in the top 10 over the 5 years. So I was like, what's changed, right? And this is, again, remember how we talked about that exploratory data analysis needs to be that curious, like creative process. Well, if you see something where you're like, huh, that's weird, follow up on it, investigate it, figure out what happened. And so we're going to do just that. So democratic socialism, right. That's one of the places I'm applying for jobs is Denmark. So, we can look and we can see exactly some of the data that we were just looking at. Poor Canada. So let's find out what's going on with Israel. Did a swoop. Yeah, Israel was like, ooh, and then kind of bouncing back. Actually, you know what I'm curious about? There is a way to do this easier. Yeah. Oh boy. Okay. Yep. Sounds about right. All right. I'll suppose her. Well, anecdotes are not anecdata, right? I'm glad that for you, happiness hasn't changed, but I mean, but also look at this. This is a difference of 0.2, right? So like, it's still a drop, and it's enough of a drop that Canada's like 9th instead of in the top 5. So it was originally in the top 5 in 2015, and now it's like barely in the top 10. So we could interpret this a couple of different ways. Did Canada decline dramatically? Or did other countries simply massively increase? Oh my God, Loafbone. Okay, I told you this. We had this conversation, Loafbone. Loafbone's probably been here the longest of anyone. So Loafbone he's also our mod, so he has way too many channel points. Your hydrates count as 1. I've told you that. You shouldn't waste your channel points, Loafbone. I bundle your hydrates into 1 because I'm not going to just like chug this on stream. Thank you, Ian Alex Hart, for the bits. In any case, 2020 happiness levels visualized. Don't drink and drive, bro. That hits way too close to home. I know. I don't even want to see that global happiness data now. Just wait for the 2020. Okay. So now we're going to do the exact same thing. All right. So this is nothing fancy. There are to make this work, I need to rename some columns. So again, ignore the in place, be better than me. Don't do what I do. Some of this is just for the easiness of stream. But remember how we had all of those gross, like, we had a lot of column names changing and stuff like that. So a lot of this is the messiness that is data cleaning. So because this is more focused on data analysis, I'm just skimming some of the cleaning for you. Don't worry about this. This is also me being a bad coder. And thank you, Kavoth the Raven, for following. A Hubble break. Do we need a Hubble break? Okay, we're almost done. We're almost done. Like, this is literally like the last like 4 minutes of what I have, and then we'll do a Hubble break. I promise. Okay. All right. So, let's see. I have 3 more hydrants. Oh my God. Quellis, Justice, good Joe, don't drink a driver. All right, fine. Okay, hold on. Thankfully, these things are mostly water. 1. I will do Hubble in just a second. Hold on. And happiness was measured, Strawberry Jesus. So this is, they asked a representative sample of the population to rate their happiness, I think 0 to 10. So, I mean, this comes with all of the like standard survey methodology caveats, right? So it is self-reported. There was a representative sample, etc. Oh my goodness, you all. So many. Okay, all right. No one cares about the EDA anymore. They're just here for my dogs. Okay, so fine. I was curious. So now you get to experience curiosity. So what's interesting about this, though, is happiness rank we can ignore. Happiness score, though, look, it didn't actually decline that much, which kind of makes me think that it probably was other countries instead, like increasing their quality of life and their happiness. But pardon me, if we are to look at this, and oh, good night, Professor Sauce Cat, have a good night. If we are looking at this closely, though, but again, like, this is the interpretability of this. So freedom, I guess, is like all over the place. Trust or government corruption has been declining, so that's interesting. Generosity is hella decline, but again, that's like, it's not a decline. It's like, how much does this contribute? So I guess what are the things that have contributed the most are family. So if your scores are declining and family's contributing more, does that mean family's a bad thing? Like this again is like the shittiness of this data set is it's hard to interpret. Okay, people. You all want dogs. I will give you dogs. Oh my gosh, there's both dogs. So here you go. Now Tennessee is here. Oh, both of them? Look at the head tilt from Tennessee. So here you go. We'll do another dog break. Oh, Ten's the one getting the treats this time. Hubble doesn't even want to give up or get up. Okay, all right. Oh no, here he comes. These are my dogs. This is Hubble. This is Tennessee. Tennessee is the one who sings for you. So actually this is about where I was going to end this stream. So I will go and collect Tennessee. I have to put my green screen down. And collect Tennessee so he can sing for you. Loafbone, can you put together a poll so Tennessee can sing? But in the meantime, though, I know this was like a whirlwind tour, and I think it was really authentic, though, to use a data set that had problems because, oh my God, they're staring at me. Fine, you can have more treats. I think it's more real to life that you're gonna get a data set that's messy, that has problems. I can't tell you how many times I get data sets where I'm like, what does this column even mean? And people are like, oh, I don't know. I don't look, there's no data dictionary. It's kind of like figure it out. And I've had to scrape it together from like reading reports and like weird logs of stuff and like going into like sensor manuals. And it's, in any case, this was a much more realistic display of what data can look like than the beautiful data sets that we were working with for Machine Learning Miss. So something to keep in mind, but we've just scratched the surface really, especially when it comes to data science as a whole. So if there are, like I said, if there are topics you want me to work on or like have a stream on for the fundamentals of data science, let me know. No, it's okay, Arrhythmia. It's okay. We're just gonna do a dog song. And then we might be done because it's 10 p.m. and I have work in the morning. I'm sorry. So here's the straw poll. I'm going to pull the straw poll up. I'm going to vote for Stargate SG1 because I love when 10 sings to that. It didn't even count my vote, so whatever. I will be right back. I'm gonna get the pupper, and when I come back, we'll have a song. Okay? So I will be right back. Hi friends. Okay, I'm gonna set up the camera. Give me 1 sec here. Okay, yes, everyone voted for Stargate. I vote that too. Okay, hold on. Webcam. Give me 1 sec here. I gotta like take off the filter thing. Crop pad. What is that? So, and then I need to unlock this so we can make this really big so you can see my dogs. I'm gonna prep this for the diva. The diva's here already. This boy. Also, I got cold, so I got a blanket. Okay. Let's see. Okay. All right. Okay, Tennessee, you're gonna need to back up so people can see you. Yes. Okay. Are you ready? Are you ready? Hubble, come on. Come on in, Hubs. Hubble, come on. Good boy. Good boys. Okay. All right. Yeah, the last one had my green screen stuff on it. So, okay. Hold on. Okay, are you ready to sing? Oh, sneezes of excitement. Okay, well, there's no music yet. You're really jumping the gun here, Tennessee. Yes. Yes, are you a good boy too? You're just here for the bribe. That is the turkey breast. Okay. Tennessee. There's no music yet, bad. Stargate SG-1 theme. Okay. You ready, friends? All right, here we go. Oh, let me turn, I'm gonna turn off the music, and I'm gonna turn down the mic because he's loud. All right, so volume warning. Oh my God. Okay. I'm starting to, hold on. Okay. I know, Tennessee. That was such a good song. Here you go. Good job, Hubble. You gave some backup vocals. So, to give Hubble a chance to, to show off as well. Hubble down. Here, Tennessee. Move over. Hubble down. Down. Good boy. Hubble up. Yes, good boy. Hubble kiss. Thank you. Here you go. Okay, you're being cute. Hubble paw. Okay, Tennessee, you're in the way. He's not going to do it if you're in the way. Stay. Tennessee. Paw. Yes, there you go. Good boy. And here you go, Ten, because you're cute too. All right. Hubble's more of the trick person and less of the singing person. Okay, bye, Hubble. I have no more turkey, so Hubble doesn't love me anymore. But thank you all so much for stopping by. And I will see you tomorrow for our first Math Monday stream. So stop by. And in the meantime, please join the Discord. I will put up the VOD. It takes YouTube forever to process this stuff, but I will post the VOD of this stream as soon as possible on YouTube. The code and the Blackboard images will be up on GitHub, though, right after the stream. So I will see you all tomorrow. And join the Discord, hang out with me, chat with me. But I'll see you all tomorrow. Have a good night. Say bye, 10. Say bye, 10. Bye. Good night, everyone.